All right. Hello, everyone. Thanks for coming. Sorry about the room mix-up. Leo's out, and so we're sort of confused. The agenda, I'll post the agenda URL here. If you have anything you want to add, go ahead and add it now. But I thought we would start by just talking about, Bruce, do you mind muting? I can hear you blowing on your microphone. Thanks. Thought we'd start by just talking about a little bit about what the Rados roadmap is looking like going forward. Just kind of a high level.
Are you recording this, by the way?
Yes.
Video?
Yep, it's recording. Yeah. Right, high level overview of where we're going, kind of what's being planned and so on. Josh, do you want to talk a bit about that, or do you want me to do it?
Why don't you go ahead and start?
All right. Yeah, I mean, so I just wanted to talk about just sort of high level stuff so people know where we're going. So the general trends are that hard drives are getting bigger, and people will be using those for like bulk colder storage. But NVMe is becoming increasingly common and standard, and there are going to be a lot of flash only deployments going forward, and it won't be long before everything is flash. So we need to go fast and sort of live in that world, which is not really where we grew up. So there's a lot of attention and effort and work going into performance refactoring. It's a little bit up in the air still, but the likely path is that we're going to embrace DPDK and SPDK for doing the network and the storage I/O. I think those will still be optional, though. You'll still be able to use sort of the other interfaces as well. But we want to make sure that if you do sort of opt in to that environment, that we can take advantage of it. And so that's probably going to drive a lot of the architectural decisions. The main piece of work that has to happen to really take advantage of that performance is a lot of refactoring in the OSD. So there's sort of cleanup and refactoring just to make the code more modular, more asynchronous, and event state driven. We're looking at futures programming frameworks to sort of enable that and make it a same programming environment. That's the main direction that Josh and Greg are investigating right now. So I think I just want to make sure everyone knows that. I guess that's a high level. Do you want to go into any more detail about what?
Yeah, sure. So maybe a little bit more detail there, kind of related to preparing for really very, very fast storage in the future. In the long term, I think we want to think about where we need to end up to be able to take advantage of such fast devices. And increasingly, it looks like that's user space, networking, and storage access, like you mentioned, with probably SPDK and DPDK. But also most likely a shared nothing architecture where we don't have to do locking to share memory between cores as much as possible, and on the fast path to keep everything within a single core. So that kind of informs our decisions in terms of how we want to structure the code a bit more than even just a asynchronous framework. So there'll be more preparation, I think, in decoupling different structures so that existing things in the OSD that aren't already sharded by PG can be sharded and shared less between different cores in the future. Yeah, I put a little summary of that in the async OSD pad at the Ost Refactoring topic at the end of the schedule there.
Cool. Okay. I think just more generally, one of the key things that needs to happen, in addition to just changing some of the structure of the code, is also just making the code a lot lighter weight. We do a lot of parsing of data structures and copying things around as we move through the stack. And as we move forward, we need to eliminate a lot of that extra work, at least for the fast path for actual I/O requests. So the goal at the end of this, as if there's really an end, but the goal is that when the data comes in off the wire, it's going to land in memory and be largely unchanged as it traverses through the stack. Whereas right now it's, it lands in a buffer, gets copied into user space, we parse it into a bunch of other data structures in the message class, and then we build a couple different intermediate representations of the transactions, and eventually it goes out over the sorts. There's a lot of stuff that happens right now that we want to simplify. And the result is that we burn a lot of CPU just doing I/O, and that's becoming increasingly expensive. That the CPU is the bottleneck and not the network and not the.
Yeah, so an explicit consequence of that is that we want to avoid memory allocations as much as possible and move towards only doing that one initial one up front for I/O ops.
Yeah.
How much of that can be done before we actually look at any particular features implementation?
It's probably some of it could be. In my mind, there's sort of two complementary but somewhat orthogonal pieces. One is trying to streamline the data structures and the allocations as they traverse through the stack. And I haven't looked as closely at the I/O path. Honestly, right now I was just looking at the peering stuff, but I noticed in the peering path there's like so many layers that are totally unnecessary. Like allocating a new thing that points to the other thing and copies half the fields over, but not all of them.
Yeah, the pairing path has nothing to do with our I/O performance.
No, I know. I'm just saying as a illustrative example, perhaps.
Yeah, it's just something we haven't been focusing on in the past, so the existing code doesn't really take it into account, and therefore there's probably 10 or 20 allocations at least per I/O or something.
And there are a lot of a lot of copies of things. Like the HObject structure is a string that copies data that's in the original message, which is a decoded copy of the thing that actually was read off the wire, and so on. So I think there's a lot of stuff like that where we can just sort of, walk through the code and look at where data structures can be combined. I mean, this is something that Matt's team did a lot of a long time ago. I think those same ideas apply, and it's sort of tedious and takes a lot of work, but there's sort of that path of just reducing the amount of computation and work that CPU has to do and memory accesses and so forth. And the other complementary piece is the structure of the code so that it's understandable and state driven, and so that it can be composed in a way that is sort of run to completion style as opposed to the threaded blocking style. And they sort of, these current need to do both.
I think part of being more careful about that memory, though, is like just having a block of memory that's in use for the op and being able to allocate out of that, which means knowing how much we need to allocate at a time. And we could probably do that without doing futures, but to my mind, it's almost as much work because we need to map out every path. And then if we didn't just have something automatically adding them up, then we need to every time we change something, we need to be like, oh, does this add more required memory to the per op stack, and go back and modify them. So C-star doesn't help a lot with that. The Tokyo model does, and I don't know how pretty the syntax would be, but we could build the same thing as Tokyo is doing in C++, or at least most of it, enough to do the automatic memory allocation.
Yeah.
The Boost ASIO library is really smart about allocations that way also.
Sorry, what library was that?
Okay, can you, we just talk about that? I was looking at ASIO and that didn't really seem like it was to me. Like it looks like it'll do upfront allocation for a future, but that if you stack them up together, then they don't combine. So you're doing an allocation on every execution unit.
Right. Futures do their own allocation, but internally for normal ASIO handlers, they each handler will allocate memory and then free it before it calls the completion, so the completion can reuse the same memory. But futures do allocate internally, so that's different.
Yeah, and so you need sort of a memory allocator, and that memory allocator can be more efficient than calling malloc, but it doesn't give you any help in figuring out how much you're going to need, like the maximum amount you're going to need for an op. You just sort of shoot it off in hope, right?
Okay, so I don't think that we need to necessarily get into all of this right now. I wanted to just provide a bit of an overview, just to make people aware of what the current efforts are. So yes, lots of investigation on the Boost ASIO front and on the C-Star front, on the futures front, and a lot of decisions to be made there. So if you have experience in this area, or if you're interested in it, please chime in. So there's that. The other sort of big things on the Rados front. I wanted to mention tiering. So cache tiering has been a bit of a black sheep in that it didn't work as well as we hoped, and we sort of discouraged people from using it because it doesn't solve all the problems that we'd hoped, and the code's hard to maintain. The high-level plan there, and I use plan loosely because nobody's actually doing this work, but this is, I think, the direction that I'm at least looking at. Chime in if you disagree, is to replace or supplement the current tiering functionality with a more traditional tiering model where the objects in the base pool are redirects or pointers to another tier, and then reuse a lot of the same pieces around promotion and demotion and proxying reads and writes that we did with cache tiering. But eventually, once we have, if we can get to roughly equivalent functionality using that tiering model, where you have the full index in the base tier instead of having this sort of sparse, maybe you have the object, maybe you don't in the cache, then we could just remove the cache tiering, deprecate it in a release, and then remove it, because people could migrate to using the new tiering model. That would be, I think that's the hope, or my hope, because that'll strip out a lot of complexity around a bunch of stuff with dealing with the case where you don't know whether the object exists or not, and you have to be correct despite that. Whereas with the model where you have a full index of the objects and the object might be there or it might be a redirect to somewhere else, you sort of know the full story and you can behave more simply. Does that jive with your hopes and dreams, Josh?
Yeah, more or less. I mean, I think I'll leave a lot of the code there that I would ideally like to not be there, but it's kind of inevitable that we need something like that to appear. So that seems like a good path forward.
So why do you think this is going to perform better, Sage? Just because we have all the indexing upfront, or?
I'm not sure it's really about performing better or worse. There are cases when cache tiering where things are slow because you don't know whether the object exists, and so you might proxy through to the base tier just to find out things like that would be better. But more generally, I don't know that it's going to be that. It's not really a performance thing. It's a code simplicity, an architectural simplicity thing. And it's a bit more flexible, right? Because you can have multiple slow tiers. We can plug the deduplication stuff into this. You could plug, tiering off to Azure or something, or Glacier or something, into the sort of model, whereas that doesn't make any sense with the cache tiering model.
I mean, I get why it's more flexible. I guess I just don't. Even if it gets feature parity, it doesn't seem to me that we're still going to discourage people from doing it, because it's not going to. At least if you want it for making your storage faster, it's not actually going to do that any better than what we currently have. It just will be easier for us to not break and to work on other features around it, which is good.
Yeah.
But that doesn't mean
Yeah.
we can tell people to do it. It'll just be like, well, no, we have this instead, but you still shouldn't use it. At least not for making your storage go faster.
Sage, I think we maybe lost. Oh, maybe you are there. Sorry.
Yeah, sorry. Yeah. Yeah, again, I'm not really thinking about this in terms of performance. I'm thinking about it in terms of being able to, well, I guess it's kind of performance. I mean, being able to keep the hot data in on fast storage and put all the cold stuff on slow storage, but still maintain the sort of the uniformity that Rados provides. This will do that better.
Right, but I mean, that's
more importantly, it'll simplify the code.
Data, you've got the really expensive promote, so you need the huge ratio of cache to.
No. So all the promote issue is gone more or less with the EC stuff, right? Because we can proxy reads and writes. So that's already sort of issue is resolved with the cache sharing. I think the main issue with cache sharing is just that the code is so complicated and fragile and hard to maintain.
No matter what we do in terms of kind of how we get there, it still seems like it's this trade-off between trying to put hot data on the cache tier versus just kind of letting any data sit in the cache tier and not doing excessive promotions, right? I mean, no matter what we do, we're not going to get around that kind of fundamental fact that if we
can't. Yeah.
Yeah, we're talking about slow promotions because we're doing it over the network, right?
Mm-hmm.
So I mean, I think regardless of what the code behind this looks like, we're not going to get around that fact. We just kind of have to accept that we're not really talking about accessing hot data on the cache tier. We're lucky if we can access some hot data on the cache tier, but I think what we're more talking about is just having some data on the cache tier and not kind of overwhelming the rest of the cluster with excessive promotion.
The way I think of it is that what we have right now has sort of no upward mobility and is fragile and hard to maintain and kind of sucks in that respect. Whereas if we make a lateral move to doing a more traditional tiering model, then we have lots of sort of upward mobility. And we have a simpler sort of architecture to support. So, because we could, for example, have not do full object promotion, but have like part of an object in the thing in the base tier, and then have part of it be in the back end. That was something that was like super complicated and really weird to do with a cache model because you don't have the full picture of what the object should be at that layer. And having the sort of hybrid, whatever, it got really gross. Whereas when you know that you have sort of the authoritative view of what the object should be, whether or not you actually have all the content there, those sorts of things become much more reasonable. And I'll sort of align nicely with what the dedupe folks are trying to do also, where you have bits of an object stored in other places.
Sorry if I'm totally missing this, but are you still thinking about what the proposal that the one dude, sorry, I forgot his name, made for Blue Store?
Young Wong?
Yeah.
Oh no, that's something else. That's Ken. So
I know.
So Ken is looking at tiering in Blue Store.
Yes, and that's why I was wondering, is that still part of this, or
no?
I know it's different.
This is Rados tiering.
Yes, but I'm wondering, is that still fitting in the picture somewhere?
Not this picture, no.
Okay, but a picture.
It's like I feel it is totally separate, and actually I'm not really thinking about it. So
okay,
yeah, I mean I think those. Yeah, I'm not too concerned about it.
Well, I guess what I'm wondering is that they both have at least some overlap in terms of what some people are trying to solve, right? You've got SSDs and you're trying to figure out what to do with them.
Yeah, but I think I think we should be looking like 2 years past that, where people have SSDs because that's the cheapest most reasonable, cost-effective storage to buy. Not the cheapest, but the most like reasonable storage, the default storage choice. And then maybe they have some hard disks because they have a bunch of cold, big data. And how should we do that? Whereas right now people view flash as a special case. I think we need to switch it so that we view hard disks as a special case. And that's gonna like maybe not be ideal for the next short little bit, but it won't be long before it will be. And if we just think ahead and like plan for that, then we'll, maybe save ourselves some effort.
I guess the question I have is, okay, so we're going to have potentially Rados level cache tiering. We're going to potentially have some kind of tiering capability in BlueStore. We already do, but maybe a more sophisticated one. When a customer comes in and asks, okay, I've got 3D cross-point storage, I've got NVRAM, I've got SSDs, and I've got hard disks. What do I do? I guess that's kind of what I don't see. We have any kind of coherent picture for them in all of this to say, this is what you do.
There's still going to be different ways to compose it, I think, regardless, and you'll have to sort of decide. But for now, at least, we have a limited set of choices.
It's the same kind of problem we have today, right, with all kinds of hardware that people use today that they have to compose in different ways in terms of journals and OSDs and different combinations of box sizes. So I think it's the same sort of situation where we test out different configurations and see what works and recommend those.
And there's never going to be one answer that's always right for everything.
Yeah, no, you're right. The Rados level tiering is just a very complicated piece of it, right?
Yeah. Yeah. So the goal with moving to tiering instead of cache tiering is that it's a less complicated implementation, and while also being more flexible and avoiding some of the issues. Anyway, right. So that was the other thing I wanted to mention. So the performance work, the general thinking on tiering. The challenge there is that the only people working on it is Youngwon, who's doing the dedupe stuff. I'm sort of making him do some of the tiering work because it's necessary for the dedupe anyway. But there's a lot that will eventually be needed to sort of let us totally deprecate cache tiering that he's not going to do. So at some point, somebody will probably need to step up if we want to make the leap. But there's that. The other thing I wanted to mention, and this is mostly just me, is I'm interested in allowing different types of pools in Rados. So right now we do replicated and erasure coded pools, but both are based on primary log. The primary copies log, so they're all synchronous, log based. I've been making baby steps towards cleaning up the PG interface and sort of inching towards some of the performance stuff, trying to do some cleanup to make that a bit easier. But partly my thinking is that if we can clean up that interface to the point where you can implement like a trivial new pool type that perhaps doesn't even do anything sort of robustly or anything, but at least is something that you can run and benchmark against, then that'll make it easier to do some of our other development. For example, we can make a non-replicated pool that just writes straight to SPDK just for kicks, basically, and then that'll let us benchmark other parts of the OSD and the message path or whatever to get a sort of a baseline idea of what we could do. But there are other folks who are interested in different types of pools too. Ones that write in parallel to multiple replicas and do like 2 out of 3 type of semantics. Slightly different consistency model, but that avoid some of the latencies you see when you have failures. For example, there are a couple different options. One of them that sort of came up recently was just thinking about fabric architectures where you have compute nodes attached to a bunch of NVMEs over a fabric. Right now, if you run Ceph on something like that, then you write to one OSD on one CPU. It replicates it writes to the to its quote unquote local NVMe over the fabric, but then it sends it to another CPU to write to its sort of directly attached NVMe over the fabric. And so you end up hopping across multiple CPUs, all so that eventually you'll write over a fabric anyway. In that sort of environment, it would make more sense to have the OSD just write to like all 3 replicas or erasure code shards directly over the fabric. But it totally like upends a lot of the other stuff away around the way that PGs are sharded and the devices are divvied up and so on. So it would be a totally different backend implementation basically for Rados. But if we decided something like that was interesting, then you could conceivably make a Rados pool type that would work on fabric hardware that would still allow you to use all the other bits of Ceph, like all the Rados, RVD, RGW, Cephfs stuff would all still work. And you'd still provide this sort of Rados level abstraction. I'm by no means an expert or like visionary on the fabric front, but my sense is that it solves sort of one axis of the sort of storage problem where it lets you talk to remote storage, but the key thing that Ceph does is redundancy and replication for fault tolerance, and fabrics don't solve that at all. Maybe they have multipathing or something, but you still have to actually have your data land on multiple devices and have something that sort of mediates access to that so that when a device fails, you can maintain availability. And I haven't really seen what is filling that gap. I don't know if people are just using like things like DRDB or something, and I don't know, whatever. I'm not really sure where people are going there, but Ceph could go there.
Yes.
And I guess go ahead.
I just want to circle back at the end to the topic. Sorry.
Yeah. Okay. And then the last thing I'll mention is that we had a discussion last week in the performance call about the messenger and making the on-wire protocol more efficient and sort of what it's going to look like where you're having stuff come in over the network and land in memory and you don't want to copy it around a bunch. There's sort of a discussion going on with the DPDK people at Intel. We're going to meet next week, but they're moving towards VPP, which is part of FD.io, which is one of the TCP stacks based on DPDK. But we're sort of looking at that. But I don't know much about it yet, so we'll see. Stay tuned. I don't know. That was basically it. Anything else just high level you want to mention, Josh, to make sure people are aware of?
I think that's a pretty good summary.
All right, cool. Okay, so a couple other things. I want to do a really quick shout out about the librmb thing that Deutsche Telekom and 42on are working on. This is a library that does mail on top of Rados and partly Cephfs right now, but I think that's sort of a temporary thing. It's a plugin for Dovecot. They presented at the OpenStack Summit in Sydney about it, and they've talked at, I think, some of the Ceph meetups. I don't know the link handy right now. Maybe somebody else can post in the chat, but just so people are aware. The other thing is I wanted to talk a little bit about what the plans are for the dashboard for Mimic. So this is work that Red Hat is planning on doing, hopefully with help from others. So there's, I'll paste the pad. The MVP plan or whatever for what is going to come in Mimic, I just sort of quickly summarized in this pad. Hopefully this is all going to happen. It really depends on how quickly we can get people spun up on this, and that's ongoing, so this might change. But the idea is basically to extend the current dashboard that's in the manager as a more robust UI for managing Ceph. Right now it's sort of a glorified Ceph-S, but this will extend it so that it has more complete status of the cluster, so you can see what the monitors are doing, what the OSDs are doing, MDSs. You can look at pools and the PG states, whether they're healthy and replicating, recovery, all that stuff. There's already an RBD status tab So there's probably not a whole lot to be done there, but probably more. So you can see how many images you have, which pools are RBD, how many images, which ones are in use, which ones are being mirrored. iSCSI gateway status would be a new thing, showing your iSCSI gateways, whether they're up and down, how busy they are. The CephFS stuff is already there to some degree, but it's pretty primitive. The main new thing would be around RGW, showing what the RGW zone groups are and zones, and what daemons are running for the zones. So those would be the basics. Right now, there's no authentication for the dashboard, so we need to add something. At the minimum, we just need like a basic user password. Probably we're also going to want to have something that lets you either use LDAP to authenticate against something else, that's a maybe, or maybe use OAuth, maybe, or maybe something token-based so that you can have, if you're in some other UI, you can click through into the Ceph one, and if there's some back channel thing, then you wouldn't have to log in again or something like that. Not quite sure exactly what that's going to look like. That's, I think, more TBD. But the other sort of big piece is that the Ceph metrics Grafana dashboards that are right now sort of separate standalone weird thing that you have to install. The plan is to take those and basically pull those into the Ceph dashboard. So we'll be embedding Grafana in, I don't know if it's in an iframe or not, but basically embedding all that Grafana stuff into the dashboard. So you get all that stuff natively. And eventually it'll live inside the Ceph tree. The upshot of all of this is that you'll install Ceph like normal Ceph, and you just do basically one command to turn on the dashboard and maybe set your user or whatever, and you'll be able to log in, you'll be able to get access to all this stuff with a standard cluster. The metrics will be backed by Prometheus, so the metrics won't really be useful unless you also have a Prometheus thing sort of sitting next to Ceph that's gathering all this stuff. And then there's planned some basic management functions. So write access stuff where you're creating pools, updating CephX keys, and the main initial stuff will be around RGW so that you can create users, buckets, access keys. That's one of the more awkward things to manage right now, and you have to do it through the CLI currently with Rados Gateway Admin. There's a ton of other stuff that's sort of on the roadmap. This is sort of the minimum stuff that we'd like to get done for Mimic. So if any UI developers out there or anyone who's interested in Ceph management stuff, now would be a really great time to raise your hand and get involved, because there's a ton of low-hanging fruit, really easy to start getting involved and hacking on this stuff, and help sort of shape the direction that this goes in. Eventually, this is also going to do things like, deploying OSDs, replacing OSDs, all the other stuff. But for the first pass, I think we probably won't get to that stuff yet.
If I can just jump in here real quick.
Yes.
So at SUSE, we actually kind of use this exact stack for monitoring, Grafana and Prometheus, and OpenAttic pulls those dashboards in as well. So thumbs up for that approach. That works really well, I think. We also have quite a few dashboards already that would be great if those went upstream, and I'm happy to contribute to the Prometheus deployment stuff and configuration stuff.
Awesome. Yeah, that'd be great. Yeah, we definitely want to. I don't know. I haven't really worked with the Grafana stuff, so I don't know if you can just like sort of take the dashboard definitions and we'll just like plop them into the source tree with a few modifications. I don't know if it works like that or not.
That's what we do right now. Like our
Awesome.
Dashboards live in our deployment tool as JSON files, essentially.
Okay. Yeah, I think partly one of the goals of all this is to like a bunch of people have built a bunch of Grafana dashboards for their big deployments. Is to have some common repository. And
yeah, we are working on this. So we started out with just something to have something, but we are actually getting some very valuable customer feedback on what they actually want. Awesome. And awesome. That'll make some big strides.
Is there a path to converge the dashboards that you're surfacing in OpenAttic with what lands in tree for the in-tree dashboard?
I would think so, yes, because OpenAttic essentially, as you said, gets an iframe from Grafana, and
okay. Cool.
So
That'd be awesome.
That would be, yeah, I agree.
Good. Okay. The other sort of bit of this is that because all this stuff lives in the manager, John's working on some changes and improvements there to make it easier to sort of reuse code in the manager across different modules. And one goal of that and consequence of that is that the stuff that we sort of enable in this dashboard will be easily exposable via the REST API as well, so that if you want to trigger the same functionality using the REST API, you'll be able to do that with minimal friction too. Hopefully that'll be useful for other external dashboards. All right. And that's enough of me talking for a while. Should we talk about the RGW Cloud Sync? Let's see yep, there you are. Yep, and I think, is Yehuda, are you here? Yep, okay.
Yeah, I'm here.
All right.
Can you hear me?
Yes, yep, take it away.
Okay, wait a moment. Can you see my screen?
Yep.
Yes.
Okay.
Yep.
Oh, hello everyone. I'm researching a cipher from Tencent Cloud in China. Just before I start talking, I want to say that my English is not pretty good, so hope all of you can give me a little more patience. And now let's begin. Recently, our team are working on sync data from RGW to COS. COS is a public object storage service of Tencent Cloud. Its API is almost compatible with S3. So we testing Yehuda's branch about Cloud Sync plugin. And now we can sync data from RGW to COS as expected. So we just want to talk some about the related work we have done, then discuss some problems we encountered with all of you, and maybe our experience can offer some help to those who also focus on this lecture. My talk contains two parts. The first part is the main problems we encountered when testing this plugin. The second one is the future work on data sync. Now let's take a look at the problems. The first problem is sometimes the RGW coroutine is blocked in some request. At first, we broke in creating a bucket, then we just add some debug log, and we could not see the debug log after create bucket request. After that, we try to create a bucket manually, but the CR is also blocked in post resource when sync object. While CR dump, we can see that the request complete in RGW post REST resource CR is not invoked. Deep into RGW HDB client, we found that the variable which identify whether ports are not in curl haven't been initialized. So the curl will not exit and the CR will blocked. So what we need to do is initially ports in RGW HDB client to avoid returning curl with function ports. That's the first problem. The second problem is about the factor of 100 continue. At first, instead of sync data to S3 directory, we use RGW to stimulate S3 service. We found that HTTP flow will broke if 100 continue is not disabled correctly. For example, if the target RGW disable it, but the client don't disable 100 continue, since S3 support 100 continue, it should not have effect on syncing data to S3. But back to reality, clients should disable 100 continue if target server do not support it. In addition, in RGW, the RGW should respond with 417 rather than 200, if not support 100 continue. The next problem is data sync will fail after recreating a bucket. Take a look at the related logs. We found that the op of creating the op of create a bucket will return with minus e not empty, but at RW AWS handle remote obj cbcr, if the op's red code is less than 0, data sync cr will exit. So we should judge whether the bucket exists via red code. If the bucket already owned by you, the data sync coroutine should continue. Otherwise, it should exit. But to be honest, the red code here should be minus error bucket exists rather than minus e not empty.
Now, I have a question here. Were you running it against RGW or against your cloud solution? Don't remember the name. That you got the 409.
Because we have a error in when pass the HTTP status code to the error number.
Right.
Yeah. From related logs, we find that the red code now is in minus e not empty. But when we recreating a bucket in S3, we will get a response with 109.
Right.
Yeah.
My question is, why did you get the 409 with 409? Is it because you were running it against? Were you, when you were using a server to sync to?
Yeah,
are you using RGW or are you using your cloud solution, cloud system? Is it returning 409 if we try to recreate a bucket that already exists unconditionally?
Oh, wait a moment. In the RGW AWS handle remote object CR, at now we will recreate a bucket for every object, and when we sync data to S3, it will respond with the HTTP code with 109, and
right.
And
are you syncing it to S3? That's my question. Where are you syncing to? Just that you're getting the 409?
Yeah.
You sync to S3. Yeah, I probably don't use the default the region though, so that's why you're getting the 409. Yeah, was just curious. Okay, thank you.
Oh, thank you. Or maybe we should somehow just pass the HTTP status code here. If the bucket via the HTTP status code, we can judge whether the bucket is already owned by you. If it's already owned by you, the data sync coroutine should continue.
Yeah.
In addition, we should avoid creating a bucket for every object. As now it used a map in in the RGW AWS handle remote BGS CBCR, but it's useless. Maybe you should move it to the sync model level.
Yeah, it needs to be in the instance of the sync module level. We need to keep that there. That's a bug that I was aware of. Yeah.
Yeah. And the next problem is the field names in request headers are in wrong format. All field names are in uppercase. If we use this format to send a request, S3 will require a date or authorization. In fact, in S3's document or standard HTTP header, the field names should use camel case format. That is, the first letter should be uppercase, the rest should be in lowercase. So we just do a transformation at HTTP client level when generating the curl request, and it can work in a right way. Okay, let's see next problem. The next problem is another problem is the date in request header is in wrong format. As a result, AWS will require a valid date. It's because at now the date in is in ISO 88601 date format, but in S3's document or standard HTTP protocol, we should use GMAT time format defined by RFC 1123 in request header. Another problem is virtual hosted style do not work. In fact, S3 supports both virtual style and the path style, but RGW only supports the last one. So we add a host style field in tail config to specify the related zones hosted style in request from RGW. If this config is not specified, path style will be used as default. And now it can work in a right way. The next problem is the signage do not match when slash in resource is encoded. In S3's document, the forward slash character in the object key name should not be encoded. So we add include slash param in URL encode to decide whether to encode the slash or not. When sent request to S3, we should not encode the slash in object key name. And the next main problem is multipart uploads failed to sync. At first we cannot sync the objects which are put it while multipart upload. Then we have found the related PR or master branch to fix it. It's mainly because PR log entries have been overwritten when multipart upload. This PR have been merged into the master branch. The next problem is date sync initial. The date sync initial command crashes. It's mainly because the num shards haven't been set it when exactly this command. So the solution is set shards on Rados GW, the main data sync initial. This PR have been merged into the master branch. Maybe we should do a rebase. The next problem is date sync wrong crashes. It's because when we exactly this this comment, the sync model instance haven't been initialized. So we initialize the sync model instance on Rados GW, the main data sync run. This run, we have modified it and put a PR to master branch, but it haven't been merged yet. Well, the another mainly problem is about sync a large objects to S3 via multi-part upload. When complete multi-part upload, HW will send a complete post with chunked encoding to S3, but we will get a not implemented response because SN do not support requests with chunked encoding. So we need to avoid using this. What we need to do is just set the send length in HW REST send resource to avoid use chunked encoding.
I have a quick general question. Are there pull requests with all these fixes that are either pending or have been merged yet? Have you submitted the fixes for these issues upstream yet?
Most of it either been sent against, like the stuff that's off my branch. That we have PRs against my branch that I'm taking care of. There were a couple of issues there that were, should have been against master. I think you have PRs for that specific issue, for the data sync run.
Yeah, the multi-part fix and the data sync and net fix are merged to master.
Right.
Okay.
And but there was another one that it was said that there should be a PR, but everything else is against my branch, and I merged most of it. There is still one pending PR, but it's almost there.
Okay, that's great. I just wanted to make sure. I wonder if we could skip past the talking about each individual bug that was encountered, because I think if the RGW folks are aware of it, they're getting fixed. Yeah.
Mm-hmm. I think we're almost there.
Yeah. Okay.
Oh, okay. Let's all the mainly problems we have ever encountered. Now we do a summary at the table below. Most of them have been solved, and and we will try to solve the last three one. That is, avoid create bucket for every object, and modify in RGW when it do not support 100 continue. It should respond with 417. Next is
yeah, I'm not sure about that. My issue is that clients should be able to handle 200 even if they expect 100, if I remember correctly. So it seemed to me that there is some other bug hiding there that that might just hide it a bit more, but you need to understand why there was an issue when we sent, or we got a 200 instead of the 100. It could be that it's an issue with curl, with lib curl, but we need to understand that anyhow. The question is it still a problem for you as it is?
Yeah. May I beg your pardon? Hello?
Yeah. Well, we can take it offline later on. But okay, so we have this issue.
Oh, okay. Thank you. The next to do is date sync will fail after recreating a bucket. Maybe we should somehow pass the HTTP status code to RWAW standard remote OBJ CBCR to decide whether it exists or not. We will do it later. Let's
Yeah.
Well,
the PR looked kind of okay. The only problem is that the status was weird, the one that you were checking against. So need to look at the HTTP status instead of the conversion to error number. So we need to propagate that somehow. Either that or just, I don't know, give higher priority to the other error, but that's not a good solution. So yeah, need to look at the HTTP status instead.
Maybe we will take a deeper look at it.
Yep. Okay.
Okay, that's mainly problems we encountered. And now let's take a look at the second part. On the near future, we plan to do some stress testing on this plugin. Besides this, we should be glad to do some work so that improve the related factor on multi-site, including this. First, note that we still can think of objects extend metadata, such as content type, original tag, and so on. And so does the object ACLs. There will need to be some way to map source ACLs into the destination ACLs. Second, we want to support a more complex configuration schema to provide complex rules. For example, ACLs mapping, bucket, spicy mappings. In addition, the current sync status may be a little rough and may be puzzled for those who don't take a detailed look at multi-site. So we want to improve RHW sync status. For example, adding like shard IDs, display arrows. Besides this, we can change at a detail flag to provide a detailed output of the number of buckets or objects are not synced. Last, we will try to work on get a sync status in the service map and then use it to display in dashboard and the risk healthy checks that are visible in Ceph status. That's all of our nearly plans, and your suggestions are greatly appreciated.
All right. Thank you very, very much for all the work that you put into it. There's the one thing that I was planning to look at was like the support of the more complex configuration. I started implementing that. The idea there is currently the configuration that you could set on tier config is a flat key value, list of flat key value entries, and for having more complex configuration, like that you might need arrays and stuff like that. So I was looking into somehow getting the JSON representation into the tier config. And I started implementing that, and it shouldn't be too hard. So yeah.
Okay. Yeah.
Right. Great. Thank you very much.
I had one quick comment about the status on those last 2 points. There's sort of 2 parts. One is reporting, making sure that any of the sync status is included in the daemon status portion that gets reported back up to the manager. That's certainly something that can be done now, and you can always like dump it manually. The surfacing it on the dashboard is harder because we don't have the panel of the dashboard that shows even the basic RGW stuff with the zones and the daemons and whatever else. Obviously, if you folks want to work on that, that would be awesome. But I wouldn't. If you don't, then you can still get the stuff into the daemon status now, and then we'll surface it later on the GUI. That makes sense. Okay.
Okay. Thanks.
Awesome. Yep. Thanks so much for your hard work shaking out these issues. This is great to see progress here. Maybe Yehuda, do you want to just like summarize briefly what this is all? I don't know. We sort of skipped the like overview. Not everybody might be aware of what this is all. This is all CloudSync, right?
That's all CloudSync. So CloudSync is basically taking the sync module framework, which allows us to sync either data or metadata, or like objects metadata, to a separate zone that's could be in the cloud. In this case, we're using the sync modules also for the Elasticsearch metadata indexing work, and it's basically how we do multi-zone data sync also, right? Like it's all using the same infrastructure. So the idea there is when we need to do a sync, we dump the data to S3 or to another tier that's compatible with it, and eventually it might not be as compatible. We're kind of building it to be abstracted enough so that there might be some hooks to allow other cloud providers that use different authentications and different APIs. So we try not to make it very S3 or S3 specific, but currently that's going to be the first implementation. Yeah, I think that's it.
Right. Thanks.
All
right. Any questions on RGW Cloud Sync before we move on? All right. I have a quick update on the DM clock stuff. This is mostly work that Eric has been doing here at Red Hat and the folks at SK Telecom. So I just wrote a few notes in the DM clock pad that I'll paste. The quick version is that right now mclock is merged. There are 2 modes you can run it in. One is mclock op class, which puts different types of operations on the OSD into different classes. So client ops are one class, scrub is one class, recovery is one class, map trimming is one class. I think that's it. And then it uses mclock to prioritize against those. There are config options to control what the relative mclock parameters are for those different classes. So you can put it in that mode, and it'll do its thing. That's all merged. The other mode is mclock client, which uses the DM clock actually to do scheduling of clients against each other, where you would have you have a minimum IOPS or whatever for a particular client, and so on. That's mostly merged, except a lot of the sort of bits to actually configure it aren't there. So there's sort of two issues right now, is that even for the mclock op class, it doesn't work super well currently because we aren't managing the queue depth very well at the object storage layer. The queue is too deep, and so the prioritization that we do at the mclock layer doesn't really have much effect. There were a few patches to try to fiddle with that Eric and the Booster team were kicking around, but we mostly set those aside because the in-flight I/O scheduler or outstanding I/O scheduler that the SK folks are working on looks to work much better. So the current task is to get that reviewed and merged. And there's a link to the pull request. But with that, they've had very good results. So it's encouraging. So but we need to get that in shape. So that's sort of the main blocker. The other sort of outstanding architectural issue is that you can't mix the op class and the client scheduling currently. You either use mclock to schedule background work against foreground work, or you use it to schedule clients against each other, but you can't do both at the same time. So Eric is trying to sort out how to do a hierarchical sort of composition of those two policies. I'm not sure how far he's gotten along there, but that's the current path. And then the last thing is, as I mentioned before, there's sort of missing APIs in Rados, so you can set what those client parameters are, so that they'll actually get used. So I don't think there's anything really preventing us from adding those in now, regardless of how effective they actually are yet, because that'll unblock all the other stuff. And for example, in RVD, being able to set those policies on RVD images and so on. We can get all that stuff in place sooner rather than later. So those are sort of the three sort of parallel next steps that are going on. And that's about it. Anything anybody want to add on to that? I guess, yeah, Eric's here. Anything to add? Or any questions?
So I guess one
No,
thing
that pretty much, I'm sorry, I just stepped on somebody. Yeah, that pretty much covers it. So yeah, I've got two things that I'm working on: the hierarchical version and plumbing. I haven't started yet, but to plumb in the Rados calls, and then we're waiting for the SK Telecom, and then we'll be good to go on a number of fronts there.
Cool. So I guess I was going to mention one thing we might want to start thinking about more is how to handle this kind of QoS in a faster world where we can't necessarily reorder all the requests in a queue. I don't really have any great ideas for that yet, but we can things like having the scheduling being done with our own queuing and user space at least lets us control CPU usage more, if not more finely grained control of storage utilization, which is what this is effectively doing.
Mm-hmm. Yeah, my sense is that in order for it to work in high IOPS environments, then we have to sample and do sort of a feedback loop where the sampling leads to throttling or something like that. Because we can't have a fully informed decision for every single IO.
Right.
Yeah, I don't know. I think that the good news, is that even if we wire up all the APIs around on the Rados side, on RVD or whatever, for the user-facing stuff, that is sort of independent of what the implementation is. So if we, end up doing something that isn't really mclock, it's something else. I think it should still.
Yeah,
the user experience.
Structure should still be the same for the client-facing bits.
Yeah, the DM clock parameters of reservation, limit, and wait seem pretty generalizable. We would probably aim for something like that, even if it wasn't DM clock underlying it.
Yeah. And even if, for example, reservation like didn't work, you could still.
Right.
Yeah. Yeah, having others at least. Okay. All right. I just want to mention that really quick. So my other sort of actual meaty issue is PG merging. So I wrote up some notes on this. This has been, for a long time, I didn't think we would ever get to it. The problem, as you probably know, is that we can split PGs as your cluster scales up, but you can't undo the split and merge them back again if the cluster scales down or if you accidentally split further than you should have, which makes it very risky to ever split because it's a one-way street. And so even like somebody who knows what they're doing can get into a situation where they split and then requirements change or the situation changes and they can't merge again. So it's a big issue for just usability in general because it's really easy for users to make bad decisions that aren't reversible. But even for a good user, it's still a problem. So we want to solve it, but mostly for the usability, mostly because it's for the easy cases, I think. So the basic idea here is that you would set the PG num, which is the placement behavior, to be less than the PG num. So that basically gets the PGs that were split to be sitting next to each other. And this is a similar situation after you split. They just split in place. They don't actually move. You adjust those two knobs separately. So you just, in reverse, you would lower the PGP num. The PGs would migrate so that they're right next to the thing that they're eventually going to merge with. So that'd be the first step. The second step, there's a pull request that does some of this, is aligning the logs. When you split, you basically just take the contents of the PG log and whichever PG each object lands in, it just gets moved into that log. And so the logs become sort of sparse as they're split apart. And in order to do the opposite to merge, we have to like zipper them back together. So there's the pull request that I have basically makes in the case where PGP num is less than PG num, it makes all the versions that are chosen for log entries offset so that they will be able to zipper together. They'll be non-overlapping. So they always skip over they go by every two and one's either even and odd or whatever it is. But it generalizes to not just two, but n. So that's the first bit. And there's an option in there to just debug, just randomly skip stuff, just to exercise all that code to make sure it behaves with sparse things. The second part is that I think we need to have some check and feedback on those PGs that are sitting next to each other so that they know when they've reached the point where the logs are non-overlapping and they can be zippered together. Because initially they won't be. You have to actually run for a while and age out the old PG entries and write new ones or whatever before that happens. Or have some way to force that to happen by trimming the log or whatever. But once that's the case, then there needs to be some feedback back to the monitor, manager, whatever, so that you know that these things are actually, the logs are ready to go and they can be zippered and you can proceed with the merge. And then the last thing is I think probably we want to try to make the logs line up so that they're sort of overlapping and not just totally discontiguous, or else the timeline on the log doesn't make sense. I'm not sure that actually is necessarily problematic, but I'm not sure.
It should be.
I'll get to that in a second, actually, because once I started to try to think about this in detail, I think that might be an issue. But regardless, there's that bit. But assuming you have PG logs in place, then the monitor needs to check a bunch of preconditions. It needs to make sure that the PGs are completely clean, and that the logs are non-overlapping and ready to be zippered together. And then I think it has to also make sure that in the map in which it publishes the PG num change where it gets reduced, no other change happens that's going to screw it up. It can't also mark an OSD down in that same epoch that's going to screw it up or change something because with split,
PGPM or mark an OSD down that's in that a member of any of those PGs, right?
Yeah, right. Yeah, exactly. Because in the split case, the PG can be kind of in any state. You can always sort of split it in half. But in the merge state, they have to be stored next to each other, and they have to be in a particular way in order for the merge to be possible. And I know I tried to imagine what the case would be that would actually make it not possible, that would make the merge fail. And the only thing I could think of would be that if the OSD goes down and somebody like rips out one of the PGs with object store tool and then start it up again, that was the only thing I could think of. But I don't know. hopefully that's it.
Yeah, as long as there's bugs that cause new entries to pop up that overlap.
Yeah. So then there'd be a particular epoch where the mon adjusts PG num down. And then when the OSD gets that map, it would have to do an atomic merge of those two PGs. So it would have to, when it publishes the map through the PG, it would have to like not do that and then zipper them together and then give that OSD map to the combined new PG. And I think most of these are sort of trivial, like the last update would be the max, you zipper the logs together, the stats add up, and so on. The part that I got stuck on is that when you're doing peering in general, because there's a new interval, there's all this log recovery stuff that happens. So in the case of a replicated pool, you look at the longest log, and that's the one that you put together, and then you look at the peers, and then you get their info, and you calculate missing objects and so on. I think each of those, the thing that I'm not sure about is that each replica is going to possibly zipper at a different point because there might have been an in-flight IO, so they might be behind, and so they're going to merge, but they're going to be missing different objects. And if the two PGs aren't going in synchrony, like if they're not ordered with respect to each other, the log, it's not a matter of like just looking at the tail, the longest log, because one of them might have one shard that was 100 versions behind that's missing an entry, whereas the other one has one that's 100 versions ahead that got it. So like, I wonder if when they're in this like preparatory merge state, we actually have to order the IOs to those two PGs with respect to each other. Does that make sense?
Yeah, basically starting to treat them as a single PG for the purposes of IO.
For this like preparatory period, yeah.
Yeah.
Which is going to be hard. And then that's the replication case, which I think is comparatively simple. For the erasure code case, it's weirder because you have the log roll forward, and then I think you really do need the ordering because they're the read. Yeah, it's like because the read modify write stuff that happens on an EC object actually basically holds up the log, so that other EC operations won't roll forward, even if they're in a different object, if they're blocked on that one because the log application is still ordered. So I think that's the hard part. This is going to get really weird.
Yeah, it seems like it's going to get pretty complex to manage that merging at that point then. I guess taking a step back, if we did have knew that these PGs were clean, and we were able to have like a kind of a sync point where we said just pause IO for all these PGs,
yeah,
turn their logs to 0, and start them as a single PG now. That would cause a brief drop in IO during merging, but it would avoid electric complexity.
Yeah, yeah. If we didn't have in-flight IOs, that would definitely solve the problem. Yeah. So if we did that, then there'd be a map published that said suspend IO to this range of PGs,
right?
And then the PGs would have to feedback that they'd done that to the manager, so the monitor sees it, and then the monitor said, "Okay, now merge." Yeah, that's probably a better solution.
I'm not sure if that needs to go through the monitor though.
Sorry, Greg, I couldn't hear you.
Oh, I said I don't think that needs to go through the monitor though. I think the monitor can just ask the primary to do the merge, and the primary can be responsible for the ordering.
Like you're saying that the primary can be responsible for it instead of the monitors?
Yes.
We don't have to do it, right?
Yeah.
We
I
don't
mean,
need
we don't
maps.
need to publish separate maps. We can just have the monitor publish a map that says please do the merge, and the primary on the PGs can take responsibility for doing it because they can order it with respect to IO for the whole set, right?
Right. So you'd have to have a map published that says you're in this limbo period where the PGs may or may not be merged. Please merge them. So that and then the primary would decide when it receives a thing whether it's happened yet or whether it should block the IO or feed it to which PG
Yeah.
at the prompt of.
Yeah.
And then once it's done, it would tell the monitor and then say it's done.
Yeah.
Yeah.
Because I mean, like the PG log zipper problem is going to be serious, but I don't think we need to like publish maps that tell IO to stop, at least.
Well, you know what? Actually, if you publish a map that says the split is in progress, or sorry, the merge is in progress, then the trivial implementation of that is that the OSD just blocks the IO, which is kind of the same thing, except the OSD gets to decide how it's done, right? Instead of the client not sending the IO, then the OSD would just block it.
Yeah, I was assuming that it was OSD side.
So it's kind of
blocking.
Yeah, okay. And maybe the initial implementation just like sends it back off, just says I'm merging, go away, and then once it's merged, it drops the back off. Maybe that's the way to do it. Yeah. Okay. Yeah, because I think if there are no in-flight IOs, then it's like it's pretty tractable, right?
Yeah.
We could even just drop the logs even.
Yeah, that's what I was saying originally.
Just throw out the logs, and we don't even need to do this like log alignment thing.
Right.
Just throw them out. Mm-hmm. You would basically do a one-time conversion of all the log entries to dupops.
Exactly.
And then.
Which is equivalent to trimming them down to zero length.
Trimming down to zero, yeah. Yeah, oh yeah.
Do we have any issues if an OSD goes down while this is happening, or are we okay?
See,
the
that's
process continues next time because the PGs would still be in this state set by the monitor, I guess, right?
Yeah, I guess that's the reason why I was trying to have a model where they happen in parallel, because then whenever an OSD encounters this epic, it can just do it, even in isolation as it's rolling forward its source. So it doesn't matter if it failed and didn't see that OSD map. It wasn't up at the time. So if the primary is telling it to happen and it fails, then it has to then it gets really weird. Yeah, then it gets complicated.
Yeah, if we ever get out of the active clean state, I guess that's when it gets complicated, because we were assuming that we were staying active clean during this process, right?
Yeah.
So,
yeah.
Yeah. So if we can make the process idempotent, it seems like it would be okay for ghosties to go down and back up again and continue the process.
So if the monitor publishes and says these PGs should merge now, they're in the process of merging. When the primary gets to that, it will basically peer, send a back off, quiescing IO, and trim all the logs down to zero.
Mm-hmm.
And then after all of that's happened, all the current replicas are clean, they've persisted their empty logs, and they're like clean slate, no in-flight IO. Then it'll go to the monitor and say, okay, merge, I'm ready. And then the next map that gets published and says these ones are no longer pre-merging, they're actually merged. And at that point, then the replicas will atomically just like zipper them together. Because there's no zipper or whatever, they'll merge them. and there's no unflat AO, and they're clean, right?
I'm just wondering if we can avoid that second Ost map update.
I think once we trim the logs, there's no overlap, so we're actually okay. If someone goes down, they just have to backfill it back into place in the new unified PG, right?
I guess what I'm
great, but
what I'm
it's a
worried
lot
about
easier and less latency and sensitive otherwise.
what I'm worried about is like, say you're in the state where the primary is like, okay, I told everyone to like zero their logs, I'm all ready to go, and then it's a split, and then they crash, and so one of them split and the other one didn't. Then suddenly peering has to deal with the fact that it's like it's got 2 PGs or 4 PGs or whatever that are not yet merged reporting in, but their peering state actually affects that same PG. That's the part that scares me.
I don't know that that's any different if we do the 2-stage thing, though, right? Like,
yeah,
they still have to merge.
At the epic, at the merging is driven by the OST map, and so they'll all happen at the same time. Not at the same time, but independently. And they won't talk to each other until after they've done it. So either they haven't merged yet, in which case they're catching up on maps, and then they'll merge, and then they'll talk to you after they've caught up. Does that make sense? Then you don't have to deal with unmerged PGs talking to a merged PG. They'll atomically roll forward, or whatever.
Right. Yeah, I guess that simplifies it a bit compared to making the primary do that coordination, like during the pairing process, to determine whether the replicas need to continue the merge process or not. If it's driven by the OST map like that.
Mm-hmm.
So I think that makes sense.
I mean, I guess if we're merging, then probably the cluster is less active anyway. So I mean, I'm willing to do that, but we're talking about like it's a several second IO pause, I guess.
Yeah, it's a multi-second merge, yeah.
On every merge though, which might be okay.
So I guess the other question is, how expensive is object store merge going to be?
It should be cheap. I mean, with BlueStore, it'll be cheap. It's just like a synchronous update. I think the slow part is going to be map gets published. It has to reach all the replicas. They do an IO to like persist it and do it, and then you have to like feed back that state back to the monitor so it sees it and then moves forward.
Yeah.
I would imagine to make this to minimize the impact, the monitor should like reduce pgenome like one at a time. So there's only like one
PG, yeah,
one peach happening at a time.
I'm not sure that's.
Because otherwise,
I don't think that's something we should enforce programmatically, actually, because any RBD that hits those is going to get stuck anyway. So why?
Because what I'm worried about is if you just have the pgenome, or if you whatever you prepare, you say you're merging half of them, then all of those PGs, or at least ones that are sort of contiguous with the top, have to say that they're ready before you can actually reduce the pgenome and finish the merge.
Oh, that's true.
And so you might have one straggler that like blocks the whole thing.
Yeah. Okay, that's true.
So it's a trade-off of OST map updates versus tail latency for a large number of PGs.
And in general, to minimize the impact, you just do it you'd only want one PG to like stick IO for 2 seconds. And hopefully most people won't notice that. It does mean that if you're going from like 1 million PGs to 500,000 PGs, like it's going to take a while.
Yeah.
Like, I feel like that kind of doesn't matter because they're already placed in the same place. So it's like it's a small amount of work based on what you already paid to like migrate the data to get to that point.
Yeah, this is a background operation that shouldn't really be expected to be low latency. that is, we're probably going to want to like throttle them anyway, so that we don't have too many going on at once and impacting the cluster in general. So.
Well, at least that's a workable solution, I think. So that makes me happy. That
yeah,
maybe we can have something better, but at least we have a solution. I was scared because when I was thinking about this before, I thought that in my mind it was clear how it had all come back together, and then when I started thinking about this again yesterday, I realized that what I was thinking before didn't work at all. But this I think would work. So
that's what you said last time.
yeah. Now there are 3 of us. So, okay. All right. That's all I got.
All right. So I guess the next is the Ost refactoring topic, which is a bit of a broad one. We already talked about this a bit at the beginning, but to reiterate, the background for this is that in general, much faster devices are becoming more prevalent, and over the next probably 5 to 10 years, like we're going to become most likely even more common, perhaps than hard disks. So we want to start preparing for that now before we have to do hundreds of thousands of IOPS on each OSD. So we want to start thinking about the end state to actually get good performance out of these super fast, almost memory speed devices. And that probably looks something like a shared nothing architecture where we avoid doing as much work on the CPU as possible for each I/O. So one way to do that is to chart all the work on a per CPU basis, have basically no locking and no memory barriers as much as possible, just using message passing and the copy memory bit essentially between different cores when we need to, and running everything either in a single process or multiple processes, but with minimal overlap, and eventually getting to a point where we're doing all of the scheduling, network I/O, and storage I/O in user space, most likely with DPDK for the network and SPDK for the storage devices. So in terms of actually scheduling code, there's many different approaches and ways you can format this, but the way we're currently structuring the code with lots of callbacks everywhere is pretty difficult to reason about, because the callbacks just kind of get thrown around every which way and spread throughout different layers. So you end up reading through things in many different places to figure out a single strand of execution. And it also ends up using many heap allocations and locks. There are a bunch of different frameworks, of course, around asynchronous programming, but one of the promising ones is futures and promises, which essentially allow you to structure asynchronous work as a single threaded strand of execution in the code. Doesn't one aspect of this will be restructuring a bit of the OSD code to be non-blocking in as many places as we can currently, so that we can use more these kinds of like futures-based frameworks for A, making the code easier to reason about, and B, eventually minimizing the allocations we need to do. So we've been looking at a few different libraries and frameworks that provide tools for futures and asynchrony. There is a standard future library in C++, as well as Boost ASIO framework that wraps around that basically. It doesn't really provide a whole lot more beyond the basic building blocks. You have to kind of build your own things around that in terms of scheduling and the event loops and dealing with everything else in the system. Make it asynchronous. Another one is Tokyo, which is actually in Rust, which looks very promising in terms of minimizing allocations. They have a clever way of using the type system to convert chains of futures into a single allocation upfront. So that basically it compiles to a state machine so that it can be one block of memory and going through and executing within that block of memory without having to do new allocations for each new task or chunk of work to do. That might be a promising direction to go if it's possible to implement that in C++, that same kind of framework. Then the third one we've been looking at more is C*, which is designed exactly for this kind of shared nothing architecture with very high speed polling-based interfaces for networking and storage. Although it does now support non-polling modes too, so you don't have to use the 100% CPU all the time if you're not using super fast storage or if you can't dedicate cores to something yet. The actual futures model it provides is more similar to the standard future or boost ASIO than to Tokyo, in that it does do allocation still for each future or for each task, but it is using its own per core allocator by default, which is a bit more efficient than something like tcmalloc or anything else that would need to do its own locking and memory barriers. It also makes it also has primitives that are already available for doing all the user space scheduling and prioritization and grouping different tasks into different priorities and executing ones that are for executing the same function or code, for example, together, so that you keep the instruction cache hot, or chaining them together so that you can keep track of groups of tasks together, that kind of thing. It's also a relatively new early form framework in that it doesn't actually do any releases yet, so they recommend using it as a submodule. And the major project that uses it so far is ScyllaDB, which is by the same people who wrote C*. So seems like it's still a relatively early project, but has very useful building blocks to work with.
I keep hearing Tokyo come up. Is it possible, or does it make sense to try to make these interoperate? Like, if we wanted to build something like Tokyo, would we be able to use it in the context of C*, or would we be able to build a Tokyo style framework in C* or something like that?
Yeah, so I think we would be able to, if we built a Tokyo style framework in C++, we would have to modify the C* reactor, which is the event loop basically that runs different tasks, to use that kind of those types. I'm not clear on how extensively we'd have to modify C* to make that happen. If it would involve, like, for example, rewriting all of the utility functions to use the new types, or if you just kind of do a drop-in replacement.
This feels like it would be a conversation to have when you're like locked in a room with a C* developer.
Yeah.
And ask them, like, this is why we think that the Tokyo framework makes sense.
Right.
Is that correct, or is there a way to achieve something similar in C*, or whatever? Yeah.
Yeah. And
the question whether you need to, or whether
yeah, the other question is whether you need to as well.
Yeah. Yeah. Those are nice to have.
Right.
Yeah.
It may be that the C* per CPU allocator is sufficient enough without having to do all the memory barriers and cross-core locking that we don't even need to worry about that piece of it. as much.
And if we just went with what the C star model is now, does the code that you end up writing substantially differ from what you would get with is it just a totally different way of structuring things?
So the code you get with like the C star style features versus Tokyo features would be very similar. But any of these would be kind of drastically different from the current code.
Yeah.
In similar ways.
Okay.
The main one being that you can't block anywhere in any of these threads. And once we actually do have sharding for CPU, we can actually avoid locking almost everywhere in the IO path, at least.
One thing that's really cool about C-Star's futures is that they're integrated with the reactor. So they don't have to assume that you might complete from a different thread, so there isn't synchronization.
Exactly.
Yeah.
And a while ago, Arit mentioned that C-Star is looking at implementing or integrating with C++ coroutines, which are a technical specification that's still in progress. But being able to use coroutines instead of futures would eliminate a lot of extra overhead also. So I'm really excited to see what happens there.
Yeah, that'd be interesting to see. Do you have any more information on the latest there, Casey, or is that just a potential development?
I think there was a pull request or something on C-Star's, is it Google Groups or something? So there is code, and I think it got some review. I know that the latest Clang has an implementation of the coroutines that you could play with, missing some of the standard library stuff. But yeah, it's still pretty early for that.
Interesting. Yeah.
Josh,
I would consider it ideal if we could mangle the C star futures into looking like the Tokyo ones and use the rest of their infrastructure. Personally, and it's not just about how fast the memory allocation is, but it means that we can do so much of it up front, so we have a much better lock on how much memory is available to us in case of trouble, which ties into what Alan was talking about with us at OpenStack's age, about sort of having the assigned bundle of memory. And I still need to look at it more, but I was sidelining with Sam some this morning before we did this, and I actually think we can do that in C++, and make it look pretty. So that would be the ideal thing, but we've got to get some more people in a room to look at how C star works and what adjustments we can make to its type model.
I think that's kind of orthogonal to converting the existing OSD code to be able to run this model at all.
Well, it depends on which pieces of it we think we need to get done in the first pass. But
Greg or Josh, have you guys run into anyone else that's struggling with this same kind of question? Is this being discussed by other folks as well?
I had a conversation with I forget the name of the company. It's somebody that we talked to a long time ago. They ended up not using Ceph and writing their own thing, proprietary, but they basically spent the last 2 or 3 years rewriting the whole thing to be DBDK and C star based. The only real takeaway I got was that it was a lot of work, but it paid off. It was totally worth it. So.
Did they consider Tokyo, or were they looking at other things too?
I don't think so. I think they just went with the thing that was there.
Tokyo seems like a thing that you could evolve towards over time, but solving different problems and a richer set of semantics from further up the stack. It's interesting.
It kind of feels like the bigger question initially is just what would it take to make the already big step to use U star unmodified?
Right.
And what do we need to do to get there? Because it's all the locking model is totally different. The charting. So I mean, we have all these. There isn't that much that blocks in the messenger stuff is all asynchronous, so there's no blocking there because it's all sort of already compartmentalized behind this interface.
Right.
And we can presumably make a wall around the object store. And so there's nothing really in between that blocks except for like, get attribute or something. But we still have like so many different threads. That
Yeah, so
I don't understand what the model is, I guess. I don't know.
Yeah, so I guess ideally we want to get to a point where we don't have the op queue anymore, at least for the entire OSD. We want it to be sharded, so that we don't have to do any memory barriers there or any locking there. And at that point, get rid of the PG locks since they're all sharded as well. But getting rid of the PG lock probably implies changing a whole lot of code to be safe to run exactly on one core and make sure that it's only running on one core and not touching any of the structures outside of that. And similarly with any kind of the OSD code that's not down in the PG. I guess there's a few things there that just for like gathering stats and reporting things to the monitor and handling maps and whatnot that we need to think a bit more about how to do a completely sharded world.
Yeah, well, and also everywhere we do synchronous reads needs to look like a new kind of code.
Yeah, file store would not be...
which is the big thing in the op path.
We assume the object store is like blocking for now. We just have a thread pool that runs everything for the object store.
At least a lot of mass. Yeah. Yeah. So I mean, the thing I've been trying to do with the peering work queue is to basically just get everything into one work queue, into the app work queue.
Yeah.
That's still helpful because it's consolidating, so there's a single interface for all the work, right?
Yeah.
We definitely want that.
We just want n of them instead of one.
Yeah. Okay. All right. Well, I'll continue beating that one down.
Yeah, because we still do want the unified queue for each individual shard, right? We just don't.
Yeah, and I mean they'll shard the same way we do now. PGs will be assigned to cores, so that's all. That's all good.
Okay.
This actually sounds supposed to be rational. I'll be hopeful that we can have some periodic discussion in the perf call. Maybe look at ways to do iterative prototyping pieces of things.
Yeah, I think that's a great idea.
Yep. Maybe we should talk about this on a weekly basis at least.
Yeah. I think we're getting far enough that'll start being useful. If anyone can prototype a tame reactor so we can start using C* inside of the OSD, that would be great.
Yeah. I think that's the challenge.
I thought Casey was eager to take that up, but
I think Adam was invented the term, so maybe he has to.
Okay. One of them.
Tame in this case.
Yeah, I'll meet with Adam and brainstorm and see if we can come up with something.
Okay.
We did have it's kind of hard dealing with external threads because message passing between C* threads happens over each pair of cores has a single producer, single consumer queue to pass messages. So I think an external thread would have to generate some kind of similar mapping. But once you have that, I think that gets you most of the way.
I'm not sure it would even need to be that parallelized. We wouldn't have that many. Well, no, I guess we would for the object store, right? Okay.
I mean, a prototype that isn't fast at all but just works would be a start, right?
Yeah.
And the goal would be to eventually not use it. But there's at some level, there's going to be a thing that we're going to have some random threads that are out there, like, for like the admin socket. I don't know, all the like sort of random sideband crap.
Right.
So,
well, actually, I mean, like the admin socket could run somewhere. That's not a big deal to just have a reserved core for handling certain kinds of things.
It's like shelling out or whatever, right? Like there are cases where we do like random asynchronous flow stuff. in
Yeah.
a separate thread. So
For anything with sockets is one of those places where it's relatively easy to convert to asynchronous code.
Yeah.
yeah.
I mean, like the object store is the model to worry about for sure, because we're not going to be able to make that integrated until we have something other than RocksDB, I guess.
Yeah, so looking at like SoliDB is interesting because they actually do implement some kind of what do you call it? What's the LDB structure? The same kind of tree.
Oh, the SSTs.
The SSTs based structure. But SoliDB is AGPL, unfortunately. So maybe we can talk to those guys and see the SoliDB folks and see if they're willing to relicense that.
What's the license?
AGPL.
Oh,
a Pharaoh?
Yeah.
Wow. Okay.
Not really a source code license at all.
That's the one where if it's a SaaS service, you have to share your code, which makes it incompatible with GPL and whatever else.
I kind of looked through their code and it doesn't look like there's a real convenient way to do kind of the equivalent gets and puts as just like a simple key value store as there is in like RocksDB. It's kind of this table oriented.
Database. Yeah. We want like a low level flat table store thing.
Yeah. I was kind of curious how hard it would be to implement some kind of lockless B plus tree type thing in C star.
Well, that's the thing, though. I think if we do go full share nothing, we don't really want any lockless like shared state at the object store level. We might even want independent object stores for core too.
Or just shard it somehow.
Can we still want some kind of central log though, right? We always want to have everything appending in order to a log for like PG log and debug updates, right? We don't want to. Oh, I guess on SSD it doesn't matter, but we always want.
It could be sharded. There's the one sort of piece that sucks is that the snap mapper is cross PG right now. That's the one bit of object store state that doesn't shard properly. I haven't come up with a way to fix that, but
okay, yeah, I'll take a look at that more closely too.
I don't know.
I guess the other thing I'm less familiar with on the networking side is with DPDK. I guess essentially you need one process that is the only one responsible for the network card, which sounds like it's one core handling all the network traffic and then passing off the work to other cores.
That is, I think you can tie it to a VIP, whatever you call it, virtual function, instead of the entire card.
Okay.
This is how they carve up a single NIC across a bunch of VMs. But still, mostly yes. So it'd be like an IP address per process, I think that's what that means.
So that potentially means one process per core instead of sharing.
Well, no, it means I think the assumption is that one core would be enough for servicing the network.
Okay.
Yeah, I think that's the assumption. And if it's not, then you have like two processes on the host. One per socket or something like that.
Yeah. And that's something we can certainly worry about more later as well. Not a pressing concern at the moment. But
yeah, I think that it doesn't sound like it's going to be an issue, but the thing that I worry about or wonder or whatever is that we need to make sure that if we don't do like vanilla C star, that we can still interoperate with the DPDK and SPDK that are happening on the other end.
Right.
Josh, going back to sharding the database, can we really get away with that? I mean, that would be fantastic if we can, right? But
I mean, it's equivalent to running multiple OSDs, right?
Yeah. Yep.
it like multiple OSDs on the same device potentially.
Yeah, potentially.
With the same trade-offs, right? Where you're not necessarily getting good behavior on something that likes sequential I/O.
Possibly. My assumption was that usually you'll see more devices than cores, but that may be invalid. I'm not sure.
I think that's right. I think right now for a single NVMe we're using like 3 cores or something like that. Is that roughly right, Mark? But
a little
that's
more,
too much.
but
we want like one or less per less than a core per NVMe.
Yeah, but I mean, more devices than cores is. Don't think I've ever seen a configuration like that, even when you're using hard drives.
Oh, there definitely are. I mean, when people use those like 72 disk chassis, right?
Yeah, but I thought those guys were usually using dual socket systems to serve them up with like 6.
Yeah, but
maybe only 2. Maybe it's 2 to 1 in those cases.
Yeah, you still don't have that many cores.
Yeah, but even at that, I'm more thinking like, okay, if we're doing logging for PG, right? Don't we want all of those log entries to come in to a single log rather than splitting them off into shards that each are independently logged?
The log is per IO, and so I'm not sure it'll matter too much. Unless you're talking about you can consolidate them when you're batching them up. If it's not sharded, then your batching will be more efficient, I guess.
Well, I guess how does it... Go ahead.
I mean, these devices all have like a bunch of different lanes, so I think sharding is you need all that parallelism to like keep the device busy anyway. I think sharding at some level is the way to go.
In the hard disk case, I guess is specifically what I'm meaning.
Yeah, no, the hard disks aren't going to care about this, but
yeah.
At that point, I mean, we're not going to care either.
Right.
If you're
put it down there.
I mean, for the hard disk case, we'd probably continue using Blue Store. Like, we wouldn't need a specialized backend that was able to do shared nothing.
If you can tie Blue Store into it effectively, I guess, using whatever.
Well, that's definitely going to have to happen. We're not going to have a new object store before we're ready to start deploying this code. That's why we need a tame reactor or something, is so that they can interoperate effectively for a long time.
Yeah. So Josh, then just in this world where we are targeting this thing at very, very fast solid state storage, then the idea would be we get away entirely from this idea of shared log, shared database. We just shard the whole thing out, right?
Exactly.
And then we don't even target anything that requires a different behavior.
Yeah, pretty much. And for, I mean, which things that are requiring different behavior are you thinking about?
That was exactly it in the hard disk case, with like a case where you don't want to be logging to multiple independent logs and spreading IOs across the disk, right? Or different places having.
But I mean, presumably at this point we'll be fast enough anyway that we can drive a whole hard drive with one CPU, so it doesn't matter, right? Like we'll give it as much as it can eat and absorb at a time.
Yeah, I think for the hard disk case we'll end up not using any polling because it's not necessary, and so we just go back to a thread pooled object store in the back end, and the front end is simply a bit faster with however many shards we need to use.
In that case, you just end up with a single shard.
Most likely, yeah.
Oh, yeah. Okay.
So there are probably a bunch of things that I'll have to change for this, but one that comes to mind is our existing debug logging. I think we're probably not going to be able to do almost any of that.
All right. Hello, everyone. Thanks for coming. Sorry about the room mix-up. Leo's out, and so we're sort of confused. The agenda, I'll post the agenda URL here. If you have anything you want to add, go ahead and add it now. But I thought we would start by just talking about, Bruce, do you mind muting? I can hear you blowing on your microphone. Thanks. Thought we'd start by just talking about a little bit about what the Rados roadmap is looking like going forward. Just kind of a high level.
Are you recording this, by the way?
Yes.
Video?
Yep, it's recording. Yeah. Right, high level overview of where we're going, kind of what's being planned and so on. Josh, do you want to talk a bit about that, or do you want me to do it?
Why don't you go ahead and start?
All right. Yeah, I mean, so I just wanted to talk about just sort of high level stuff so people know where we're going. So the general trends are that hard drives are getting bigger, and people will be using those for like bulk colder storage. But NVMe is becoming increasingly common and standard, and there are going to be a lot of flash only deployments going forward, and it won't be long before everything is flash. So we need to go fast and sort of live in that world, which is not really where we grew up. So there's a lot of attention and effort and work going into performance refactoring. It's a little bit up in the air still, but the likely path is that we're going to embrace DPDK and SPDK for doing the network and the storage I/O. I think those will still be optional, though. You'll still be able to use sort of the other interfaces as well. But we want to make sure that if you do sort of opt in to that environment, that we can take advantage of it. And so that's probably going to drive a lot of the architectural decisions. The main piece of work that has to happen to really take advantage of that performance is a lot of refactoring in the OSD. So there's sort of cleanup and refactoring just to make the code more modular, more asynchronous, and event state driven. We're looking at futures programming frameworks to sort of enable that and make it a same programming environment. That's the main direction that Josh and Greg are investigating right now. So I think that's, I just want to make sure everyone knows that. I guess it's at a high level. Do you want to go into any more detail about what?
Yeah, sure. So maybe a little bit more detail there, kind of related to preparing for really very, very fast storage in the future. In the long term, I think we want to think about where we need to end up to be able to take advantage of such fast devices. And increasingly, it looks like that's user space, networking, and storage access, like you mentioned, with probably SPDK and DPDK. But also most likely a shared nothing architecture where we don't have to do locking to share memory between cores as much as possible, and on the fast path to keep everything within a single core. So that kind of informs our decisions in terms of how we want to structure the code a bit more than even just a asynchronous framework. So there'll be more preparation, I think, in decoupling different structures so that existing things in the OSD that aren't already sharded by PG can be sharded and shared less between different cores in the future. Yeah, I put a little summary of that in the async OSD pad at the OSD refactoring topic at the end of the schedule there.
Cool. Okay. I think just more generally, one of the key things that needs to happen, in addition to just changing some of the structure of the code, is also just making the code a lot lighter weight. We do a lot of parsing of data structures and copying things around as we move through the stack. And as we move forward, we need to eliminate a lot of that extra work, at least for the fast path for actual IO requests. So the goal at the end of this, as if there's really an end, but the goal is that when the data comes in off the wire, it's going to land in memory and be largely unchanged as it traverses through the stack. Whereas right now it's, it lands in a buffer, gets copied into user space, we parse it into a bunch of other data structures in the message class, and then we build a couple different intermediate representations of the transactions, and eventually goes out over the sorts. There's a lot of stuff that happens right now that we want to simplify, and the result is that we burn a lot of CPU just doing I/O, and that's becoming increasingly expensive. That the CPU is the bottleneck and not the network and not the.
Yeah, so an explicit consequence of that is that we want to avoid memory allocations as much as possible and move towards only doing that one initial one up front for I/O ops.
Yeah.
How much of that can be done before we actually look at any particular features implementation?
It's probably some of it could be. In my mind, there's sort of two complementary but somewhat orthogonal pieces. One is trying to streamline the data structures and the allocations as they traverse through the stack. And I haven't looked as closely at the I/O path. Honestly, right now I was just looking at the peering stuff, but I noticed in the peering path there's like so many layers that are totally unnecessary of like allocating a new thing that points to the other thing and copies half the fields over, but not all of them.
Yeah, pairing path has nothing to do with our I/O performance.
No, I know. I'm just saying as a illustrative example, perhaps.
Yeah, it's just something we haven't been focusing on in the past, so the existing code doesn't really take it into account, and therefore does probably 10 or 20 allocations at least for I/O or something.
And there are a lot of like intermediate, a lot of copies of things. Like the HObject structure is a string that copies data that's in the original message, which is a decoded copy of the thing that actually was read off the wire, and so on. So I think there's a lot of stuff like that where we can just sort of, walk through the code and look at where data structures can be combined. I mean, this is something that Matt's team did a lot of a long time ago. I think those same ideas apply, and it's sort of tedious and takes a lot of work, but there's sort of that path of just reducing the amount of computation and work that the CPU has to do and memory accesses and so forth. And the other complementary piece is the structure of the code so that it's understandable and state driven, and so that it can be composed in a way that is sort of run to completion style as opposed to the threaded blocking style. And they sort of, he's currently to do both.
I think part of being more careful about that memory, though, is like just having a block of memory that's in use for the op and being able to allocate out of that, which means knowing how much we need to allocate at a time. And we could probably do that without doing futures, but to my mind, it's almost as much work because we need to map out every path. And then if we didn't just have something automatically adding them up, then we need to like, every time we change something, we need to be like, oh, does this add more required memory to the like per op stack and go back and modify them. So C-star doesn't help a lot with that. The Tokyo model does, and I don't know how pretty the syntax would be, but we could build the same thing as Tokyo is doing in C++, or at least most of it, enough to do the automatic memory allocation.
Yeah.
The Boost ASIO library is really smart about allocations that way also.
Sorry, what library was that?
Okay, can you we just talk about that? I was looking at ASIO and that didn't really seem like it was to me. Like it looks like it'll do upfront allocation for a future, but that if you stack them up together, then they don't combine. So you're doing an allocation on every execution unit.
Right. Futures do their own allocation, but internally for normal ASIO handlers, they each handler will allocate memory and then free it before it calls the completion, so the completion can reuse the same memory. But futures do allocate internally, so that's different.
Yeah, and so you need sort of a memory allocator, and that memory allocator can be more efficient than calling malloc, but it doesn't give you any help in figuring out how much you're going to need, like the maximum amount you're going to need for an op. You just sort of shoot it off and hope, right?
Okay, so I don't think that we need to necessarily get into all of this right now. I wanted to just provide a bit of an overview, just to make people aware of what the current efforts are. So yes, lots of investigation on the Boost ASIO front and on the C-Star front, on the futures front, and a lot of decisions to be made there. So if you have experience in this area, or if you're interested in it, please chime in. So there's that. The other sort of big things on the Rados front. I wanted to mention tiering. So cache tiering has been a bit of a black sheep in that it didn't work as well as we hoped, and we sort of discouraged people from using it because it's doesn't solve all the problems that we'd hoped, and the code's hard to maintain. The high-level plan there, and I use plan loosely because nobody's actually doing this work, but this is, I think, the direction that I'm at least looking at. Chime in if you disagree. Is to replace or supplement the current tiering functionality with a more traditional tiering model where the objects in the base pool are redirects or pointers to another tier, and then reuse a lot of the same pieces around promotion and demotion and proxying reads and writes that we did with cache tiering. But eventually, once we have, if we can get to roughly equivalent functionality using that tiering model, where you have the full index in the base tier instead of having this sort of sparse, maybe you have the object, maybe you don't in the cache, then we could just remove the cache tiering, or deprecate it in a release, and then remove it, because people could migrate to using the new tiering model. That would be, I think that's the hope, or my hope, because that'll strip out a lot of complexity around a bunch of stuff with dealing with the case where you don't know whether the object exists or not, and you have to be correct despite that. Whereas with the model where you have a full index of the objects, and the object might be there, or it might be a redirect to somewhere else, you sort of know the full story, and you can behave more simply. Does that jive with your hopes and dreams, Josh?
Yeah, more or less. I mean, I think I'll leave a lot of the code there that I would ideally like to not be there, but it's kind of inevitable that we need something like that to appear. So that seems like a good path forward.
So why do you think this is going to perform better, Sage? Just because we have all the indexing upfront, or?
I'm not sure it's really about performing better or worse. There are cases when cache tiering where things are slow because you don't know whether the object exists, and so you might proxy through to the base tier just to find out things like that would be better. But more generally, I don't know that it's going to be that. It's not really a performance thing. It's a code simplicity, an architectural simplicity thing. And it's a bit more flexible, right? Because you can have multiple flow tiers. We can plug the deduplication stuff into this. You could plug, tiering off to Azure or something, or Glacier or something, into the sort of model, whereas that doesn't make any sense with the cache tiering model.
I mean, I get why it's more flexible. I guess I just don't. Even if it gets feature parity, it doesn't seem to me that we're still going to discourage people from doing it, because it's not going to. At least if you want it for making your storage faster, it's not actually going to do that any better than what we currently have. It just will be easier for us to not break and to work on other features around it, which is good.
Yeah. Yeah.
But that doesn't mean
Yeah.
we can tell people to do it. It'll just be like, well, no, we have this instead, but you still shouldn't use it. At least not for making your storage go faster.
Sage, I think we maybe lost. Oh, maybe you are there. Sorry.
Yeah, sorry. Yeah. Yeah, again, I'm not really thinking about this in terms of performance. I'm thinking about it in terms of being able to, well, I guess it's kind of performance. I mean, being able to keep the hot data in on fast storage and put all the cold stuff on slow storage, but still maintain the sort of the uniformity that Rados provides. This will do that better.
Right, but I mean, that's still
more importantly, it'll simplify the code.
Data, you've got the really expensive promote, so you need the huge ratio of cache to.
No. So all the promote issue is gone more or less with the EC stuff, right? Because we can proxy reads and writes. So that's already sort of issue is resolved with the cache sharing. I think the main issue with cache sharing is just that the code is so complicated and fragile and hard to maintain.
No matter what we do in terms of kind of how we get there, it still seems like it's this trade-off between trying to put hot data on the cache tier versus just kind of letting any data sit in the cache tier and not doing excessive promotions, right? I mean, no matter what we do, we're not going to get around that kind of fundamental fact that if we, we're talking about slow promotions because we're doing it over the network, right?
Mm-hmm.
So I mean, I think regardless of what the code behind this looks like, we're not going to get around that fact. We just kind of have to accept that we're not really talking about accessing hot data on the cache tier. We're lucky if we can access some hot data on the cache tier, but I think what we're more talking about is just having some data on the cache tier and not kind of overwhelming the rest of the cluster with excessive promotion.
The way I think of it is that what we have right now has sort of no upward mobility and is fragile and hard to maintain and kind of sucks in that respect. Whereas if we make a lateral move to doing a more traditional tiering model, then we have lots of sort of upward mobility. And we have a simpler sort of architecture to support. So, because we could, for our example, have not do full object promotion, but have like part of an object in the thing in the base tier, and then have part of it be in the back end. That was something that was like super complicated and really weird to do with a cache model because you don't have the full picture of what the object should be at that layer. And having the sort of hybrid, whatever, it got really gross. Whereas when you know that you have sort of the authoritative view of what the object should be, whether or not you actually have all the content there, those sorts of things become much more reasonable. And I'll sort of align nicely with what the dedupe folks are trying to do also, where you have bits of an object stored in other places.
Sorry if I'm totally missing this, but are you still thinking about what the proposal that the one dude, sorry, I forgot his name, made for Blue Store?
Young Wong?
Yeah.
Oh no, that's something else. That's Ken. So
I know.
So Ken is looking at tiering in Blue Store.
Yes, and that's why I was wondering, is that still part of this, or
no?
I know it's different.
This is Rados tiering.
Yes, but I'm wondering, is that still fitting in the picture somewhere?
Not this picture, no.
Okay, but a picture.
It's like I feel it is totally separate, and actually I'm not really thinking about it. So.
Okay.
Yeah, I mean I think those. Yeah, I'm not too concerned about it.
Well, I guess what I'm wondering is they both have at least some overlap in terms of what some people are trying to solve, right? You've got SSDs and you're trying to figure out what to do with them.
Yeah, but I think I think we should be looking like 2 years past that, where people have SSDs because that's the cheapest, most reasonable, cost-effective storage to buy. Not the cheapest, but the most like reasonable storage, the default storage choice. And then maybe they have some hard disks because they have a bunch of cold, big data. And how should we do that? Whereas right now people view flash as a special case. I think we need to switch it so that we view hard disks as a special case. And that's gonna like maybe not be ideal for the next short little bit, but it won't be long before it will be. And if we just think ahead and like plan for that, then we'll, maybe save ourselves some effort.
I guess the question I have is, okay, so we're going to have potentially Rados level cache tiering. We're going to potentially have some kind of tiering capability in BlueStore. We already do, but maybe a more sophisticated one. When a customer comes in and asks, okay, I've got 3D cross-point storage, I've got NVRAM, I've got SSDs, and I've got hard disks. What do I do? I guess that's kind of what I don't see. We have any kind of coherent picture for them in all of this to say, this is what you do.
There's still going to be different ways to compose it, I think, regardless, and you'll have to sort of decide. But for now, at least, we have a limited set of choices.
It's the same kind of problem we have today, right, with all kinds of hardware that people use today that they have to compose in different ways in terms of journals and OSDs and different combinations of box sizes. So I think it's the same sort of situation where we test out different configurations and see what works and recommend those.
And there's never going to be one answer that's always right for everything.
Yeah, no, you're right. The Rados level tiering is just a very complicated piece of it, right?
Yeah. Yeah. So the goal with moving to tiering instead of cache tiering is that it's a less complicated implementation, and while also being more flexible and avoiding some of the issues. Anyway, right. So that was the other thing I wanted to mention. So the performance work, the general thinking on tiering. The challenge there is that the only people working on it is Youngwon, who's doing the dedupe stuff. I'm sort of making him do some of the tiering work because it's necessary for the dedupe anyway. But there's a lot that will eventually be needed to sort of let us totally deprecate cache tiering that he's not going to do. So at some point, somebody will probably need to step up if we want to make the leap. But there's that. The other thing I wanted to mention, and this is mostly just me, is I'm interested in allowing different types of pools in Rados. So right now we do replicated and erasure coded pools, but both are based on primary log. The primary copies log, so they're all synchronous, log based. I've been making baby steps towards cleaning up the PG interface and sort of inching towards some of the performance stuff, trying to do some cleanup to make that a bit easier. But partly my thinking is that if we can clean up that interface to the point where you can implement like a trivial new pool type that perhaps doesn't even do anything sort of robustly or anything, but at least is something that you can run and benchmark against, then that'll make it easier to do some of our other development. For example, we can make a non-replicated pool that just writes straight to SPDK just for kicks, basically, and then that'll let us benchmark other parts of the OSD and the message path or whatever to get a sort of a baseline idea of what we could do. But there are other folks who are interested in different types of pools too. Ones that write in parallel to multiple replicas and do like 2 out of 3 type of semantics, slightly different consistency model, but that avoid some of the latencies you see when you have failures. For example, there are a couple different options. One of them that sort of came up recently was just thinking about fabric architectures where you have compute nodes attached to a bunch of NVMEs over a fabric. Right now, if you run Ceph on something like that, then you write to one OSD on one CPU. It replicates it it writes to its quote unquote local NVMe over the fabric, but then it sends it to another CPU to write to its sort of directly attached NVMe over the fabric. And so you end up hopping across multiple CPUs, all so that eventually you'll write over a fabric anyway. In that sort of environment, it would make more sense to have the OSD just write to like all 3 replicas or erasure code shards directly over the fabric. But it totally like upends a lot of the other stuff around the way that PGs are sharded and the devices are divvied up and so on. So it would be a totally different backend implementation basically for Rados. But if we decided something like that was interesting, then you could conceivably make a Rados pool type that would work on fabric hardware that would still allow you to use all the other bits of Ceph, like all the Rados, RBD, RGW, CephFS stuff would all still work. And you'd still provide this sort of Rados level abstraction. I'm by no means an expert or like visionary on the fabric front, but my sense is that it solves sort of one axis of the sort of storage problem where it lets you talk to remote storage, but the key thing that Ceph does is redundancy and replication for fault tolerance, and fabrics don't solve that at all. Maybe they have multipathing or something, but you still have to actually have your data land on multiple devices and have something that sort of mediates access to that so that when a device fails, you can maintain availability. And I haven't really seen what is filling that gap. I don't know if people are just using like things like DRDB or something, and I don't know, whatever. I'm not really sure where people are going there, but Ceph could go there. And I guess go ahead.
I just want to circle back at the end to the topic. Sorry.
Okay. And then the last thing I'll mention is that we had a discussion last week in the performance call about the messenger and making the on-wire protocol more efficient and sort of what it's going to look like where you're having stuff come in over the network and land in memory and you don't want to copy it around a bunch. There's sort of a discussion going on with the DPDK people at Intel. We're going to meet next week, but they're moving towards VPP, which is part of FD.io, which is one of the TCP stacks based on DPDK. But we're sort of looking at that. But I don't know much about it yet, so we'll see. Stay tuned. I don't know. That was basically it. Anything else, just high level you want to mention, Josh, to make sure people are aware of?
I think that's a pretty good summary.
All right, cool. Okay, so a couple other things. I want to do a really quick shout out about the librmb thing that Deutsche Telekom and 42On are working on. This is a library that does mail on top of Rados and partly CephFS right now, but I think that's sort of a temporary thing. It's a plugin for Dovecot. They presented at the OpenStack Summit in Sydney about it, and they've talked at, I think, some of the Ceph meetups. I don't know the link handy right now. Maybe somebody else can post in the chat, but just so people are aware. The other thing is I wanted to talk a little bit about what the plans are for the dashboard for Mimic. So this is work that Red Hat is planning on doing, hopefully with help from others. So there's, I'll paste the pad. The MVP plan or whatever for what is going to come in Mimic, I just sort of quickly summarized in this pad. Hopefully this is all going to happen. It really depends on how quickly we can get people spun up on this, and that's ongoing, so this might change. But the idea is basically to extend the current dashboard that's in the manager as a more robust UI for managing Ceph. Right now it's sort of a glorified Ceph-S. But this will extend it so that it has more complete status of the cluster, so you can see what the monitors are doing, what the OSDs are doing, MDSs. You can look at pools and the PG states, whether they're healthy and replicating, recovery, all that stuff. There's already an RBD status tab, so there's probably not a whole lot to be done there, but probably more. So you can see, how many images you have, which pools are RBD, how many images, which ones are in use, which ones are being mirrored. iSCSI gateway status would be a new thing, showing your iSCSI gateways, whether up and down, how busy they are. The CephFS stuff is already there to some degree, but it's pretty primitive. The main new thing would be around RGW, showing what the RGW zone groups are and zones, and what daemons are running for the zones. So those would be the basics. Right now, there's no authentication for the dashboard, so we need to add something. At the minimum, we just need like a basic user password. Probably we're also going to want to have something that lets you either use LDAP to authenticate against something else, that's a maybe, or maybe use OAuth, maybe, or maybe something token-based so that you can have, if you're in some other UI, you can click through into the Ceph one, and if there's some back channel thing, then you wouldn't have to log in again or something like that. Not quite sure exactly what that's going to look like. That's, I think, more TBD. But the other sort of big piece is that the Ceph metrics Grafana dashboards that are right now sort of separate standalone weird thing that you have to install. The plan is to take those and basically pull those into the Ceph dashboard. So we'll be embedding Grafana in, I don't know if it's in an iframe or not, but basically embedding all that Grafana stuff into the dashboard. So you get all that stuff natively. And eventually it'll live inside the Ceph tree. The upshot of all of this is that you'll install Ceph like normal Ceph, and you just do basically one command to turn on the dashboard and maybe set your user or whatever, and you'll be able to log in. You'll be able to get access to all this stuff with a standard cluster. The metrics will be backed by Prometheus, so the metrics won't really be useful unless you also have a Prometheus thing sort of sitting next to Ceph that's gathering all this stuff. And then there's planned some basic management functions. So write access stuff where you're creating pools, updating CephX keys, and the main initial stuff will be around RGW so that you can create users, buckets, access keys. That's one of the more awkward things to manage right now, and you have to do it through the CLI currently with Rados Gateway Admin. There's a ton of other stuff that's sort of on the roadmap. This is sort of the minimum stuff that we'd like to get done for Mimic. So if any UI developers out there or anyone who's interested in Ceph management stuff, now would be a really great time to raise your hand and get involved, because there's a ton of low-hanging fruit, really easy to start getting involved and hacking on this stuff, and help sort of shape the direction that this goes in. Eventually, this is also going to do things like, deploying OSDs, replacing OSDs, all the other stuff. But for the first pass, I think we probably won't get to that stuff yet.
If I can just jump in here real quick.
Yes.
So at SUSE, we actually kind of use this exact stack for monitoring, Grafana and Prometheus, and OpenAttic pulls those dashboards in as well. So thumbs up for that approach. That works really well, I think. We also have quite a few dashboards already that would be great if those went upstream, and I'm happy to contribute to the Prometheus deployment stuff and configuration stuff.
Awesome. Yeah, that'd be great. Yeah, we definitely want to. I don't know. I haven't really worked with the Grafana stuff, so I don't know if you can just like sort of take the dashboard definitions and we'll just like plop them into the source tree with a few modifications. I don't know if it works like that or not.
That's what we do right now. Like our dashboards live in our deployment tool as JSON files, essentially.
Okay. Yeah, I think partly one of the goals of all this is to like a bunch of people have built a bunch of Grafana dashboards for their big deployments. Is to have some common repository. And
yeah, we are working on this. So we started out with just something to have something, but we are actually getting some very valuable customer feedback on what they actually want. Awesome. And that'll make some strides.
Is there a path to converge the dashboards that you're surfacing in OpenAttic with what lands in tree for the in-tree dashboard?
I would think so, yes, because OpenAttic essentially, as you said, gets an iframe from Grafana, and
okay,
yeah,
cool.
So
that'd be awesome.
That would be, yeah, I agree.
Good. Okay. The other sort of bit of this is that because all this stuff lives in the manager, John's working on some changes and improvements there to make it easier to sort of reuse code in the manager across different modules. And one goal of that and consequence of that is that the stuff that we sort of enable in this dashboard will be easily exposable via the REST API as well, so that if you want to trigger the same functionality using the REST API, you'll be able to do that with minimal friction too. Hopefully that'll be useful for other external dashboards. All right, and that's enough of me talking for a while. Should we talk about the RGW Cloud Sync? Let's see who's. Yep, there you are. Yep, and I think is Yehuda. Are you here? Yep. Okay.
Yeah, I'm here.
All right.
Can you hear me?
Yes. Yep. Take it away.
Oh, wait a moment. Can you see my screen?
Yep.
Yes.
Okay.
Yep.
Oh, hello everyone. I'm Lu Shanzhen, a cyber from TensorCloud in China. Just before I start talking, I want to say that my English is not pretty good, so hope all of you can give me a little more patience. And now let's begin. Recently, our team are working on sync data from RGW to COS. COS is a public object storage service of TensorCloud. Its API is almost compatible with S3. So we testing Yehuda's branch about Cloud Sync plugin. And now we can sync data from RGW to COS as expected. So we just want to talk some about the related work we have done, then discuss some problems we encountered with all of you, and maybe our experience can offer some help to those who also focus on this feature. My talk contains two parts. The first part is the main problems we encountered when testing this plugin. The second one is the future work on data sync. Now let's take a look at the problems. The first problem is sometimes the RGW coroutine is blocked in some request. At first, we broke in creating a bucket, then we just add some debug log, and we could not see the debug log after create bucket request. After that, we try to create a bucket manually, but the CR is also blocked in post resource when sync object. While CR dump, we can see that the request complete in RGW post REST resource CR is not invoked. Deep into RGW HTTP client, we found that the variable which identify whether ports are not in curl haven't been initialized. So the curl will not exit and the CR will blocked. So what we need to do is initially ports in RGW HTTP client to avoid returning curl with function ports. That's the first problem. The second problem is about the feature of 100 continue. At first, instead of sync data to S3 directory, we use RGW to stimulate S3 service. We found that HTTP flow will block if 100 continue is not disabled correctly. For example, if the target RGW disable it, but the client don't disable 100 continue, Since S3 support 100 continue, it should not have effect on syncing data to S3. But back to reality, clients should disable 100 continue if target server do not support it. In addition, in RHW, the RHW should respond with 417 rather than 200 if not support 100 continue. The next problem is data sync will fail after recreating a bucket. Take a look at the related logs. We found that the op of creating a bucket will return with -e not empty, but at RW AWS handle remote obj CBCR, if the op's red code is less than 0, data sync CR will exit. So we should judge whether the bucket exists via red code. If the bucket already owned by you, the data sync coroutine should continue. Otherwise, it should exit. But to be honest, the red code here should be minus error bucket exists rather than minus e not empty.
Now, I have a question here. Were you running it against RGW or against your cloud solution? Don't remember the name. That you got the 409.
Because we have a error in when pass the HTTP status code to the error number.
Right.
Yeah. From related logs, we find that the red code now is in minus e not empty. But when we recreating a bucket in S3, we will get a response with 109.
Right.
Yeah.
My question is, why did you get the 409 with 409? Is it because you were running it against? When you were using a server to sync to?
Yeah,
are you using RGW or are you using your cloud solution, cloud system? Is it returning 409 if we try to recreate a bucket that already exists unconditionally?
Oh, wait a moment. In the RGW AWS handle remote object CR, at now we will recreate a bucket for every object, and when we sync data to S3, it will respond with the HTTP code with 109, and
right.
Are
you syncing it to S3? That's my question. Where are you syncing to? Just that you're getting the 409?
Yeah.
You sync to S3. Yeah, you probably don't use the default the region though, so that's why you're getting the 409. Yeah, was just curious. Okay, thank you.
Oh, thank you. Or maybe we should somehow just pass the HTTP status code here. If the bucket via the HTTP status code, we can judge whether the bucket is already owned by you. If it's already owned by you, the date sync coroutine should continue.
Yeah.
In addition, we should avoid creating a bucket for every object. As now, it used a map in the RW AWS handle remote BGS CBCR, but it's useless. Maybe you should move it to the sync model level.
Yeah, it needs to be in the instance of the sync module level. We need to keep that there. That's a bug that I was aware of. Yeah.
Yeah. And the next problem is the field names in request headers are in wrong format. All field names are in uppercase. If we use this format to send a request, S3 will require a date or authorization. In fact, in S3's document or standard HTTP header, the field names should use camel case format. That is, the first letter should be uppercase, the rest should be in lowercase. So we just do a transformation at HTTP client level when generating the curl request, and it can work in a right way. Okay, let's see next problem. The next problem is another problem is the date in request header is in wrong format. As a result, AWS will require a valid date. It's because at now the date in is in ISO 88601 date format, but in S3's document or standard HTTP protocol, we should use GMAT time format defined by RFC 1123 in request header. Another problem is virtual hosted style do not work. In fact, S3 supports both virtual style and the path style, but RW only supports the last one. So we add a host style field in tier config to specify the related zones hosted style in request from RW. If this config is not specified, path style will be used as default. And now it can work in a right way. The next problem is the signage do not match when slash in resource is encoded. In S3's document, the forward slash character in the object key name should not be encoded. So we add include slash param in URL encode to decide whether to encode the slash or not. When sent request to S3, we should not encode the slash in object key name. And the next main problem is multi-part uploads failed to sync. At first, we cannot sync the objects which are put it while multi-part upload. Then we have found the rated PR or master branch to fix it. It's mainly because BI log entries have been overwritten when multi-part upload. This PR have been merged into the master branch. The next problem is date sync initial. The date sync initial command crashes. It's mainly because the num shards haven't been set when exactly this command. So the solution is set shards on Rados GW admin data sync initial this PR have been merged into the master branch. Maybe we should do a rebase. The next problem is data sync run crashes. It's because when we execute this command, the sync model instance haven't been initialized. So we initialize the sync model instance on Rados GW, the main data sync run. This run, we have modified it and put a PR to master branch, but it haven't been merged yet. Well, another mainly problem is about sync a large objects to S3 via multipart upload. When you complete multipart upload, RGW will send a complete post with chunked encoding to S3, but we will get a not implemented response because SN do not support requests with chunked encoding. So we need to avoid using this. What we need to do is just set the send length in RGW REST send resource to avoid use chunked encoding.
I have a quick general question. Are there pull requests with all these fixes that are either pending or have been merged yet? Have you submitted the fixes for these issues upstream yet?
Most of it either been sent against, like the stuff that's off my branch. That we have PRs against my branch that I'm taking care of. There were a couple of issues there that were, should have been against master. I think you have PRs for that specific issue, for the data sync run.
Yeah, the multi-part fix and the data sync and net fix are merged to master.
Right.
Okay.
And but there was another one that it was said that there should be a PR, but everything else is against my branch, and I merged most of it. There is still one pending PR, but it's almost there.
Okay, that's great. I just wanted to make sure. I wonder if we could skip past the talking about each individual bug that was encountered, because I think if the RGW folks are aware of it, we're getting fixed. Yeah.
Mm-hmm. I think we're almost there.
Yeah. Okay.
Oh, okay. Let's all the mainly problems we have ever encountered. Now we do a summary at the table below. Most of them have been solved, and and we will try to solve the last three one. That is, avoid create bucket for every object, and modify in RGW when it do not support 100 continue. It should respond with 417. Next is
yeah, I'm not sure about that. My issue is that clients should be able to handle 200 even if they expect 100, if I remember correctly. So it seemed to me that there is some other bug hiding there that might just hide it a bit more, but you need to understand why there was an issue when we sent, or we got a 200 instead of the 100. It could be that it's an issue with curl, with lib curl, but we need to understand that anyhow. The question is it still a problem for you as it is?
Yeah. May I beg your pardon? Hello?
Yeah. Well, we can take it offline later on. But okay, so we have this issue.
Oh, okay. Thank you. The next to do is date sync where after recreating a bucket, maybe we should somehow pass the HTTP status code to RWAW standard remote OBJS VCR to decide whether it exists or not. We will do it later. Let's
Yeah.
program.
Well, the PR look kind of okay. The only problem is that the status was weird, the one that you were checking against. So need to look at the HTTP status instead of the conversion to error number. So we need to propagate that somehow. Either that or just, I don't know, give higher priority to the other error, but that's not a good solution. So yeah, need to look at the HTTP status instead.
Maybe we will take a deeper look at it.
Yep. Okay.
Okay, let's mainly problems we encountered. I don't know, let's take a look at the second part. On the near future, we plan to do some stress testing on this plugin. Besides this, we should be glad to do some work so let's improve the related factor on multi-sites, including this. First, note that we still can think of objects extend metadata, such as content type, original tag, and so on. And so does the object ACLs. There will need to be some way to map source ACLs into the destination ACLs. Second, we want to support a more complex configuration schema to provide complex rules. For example, ACLs mapping, bucket, spacing mappings. In addition, the current sync status may be a little rough and may be puzzled for those who don't take a detailed look at multi-site. So we want to improve RHW sync status. For example, identification IDs display errors. Besides this, we can change at a detail flag to provide a detailed output of the number of buckets or objects are not synced. Last, we will try to work on get a split sync status in the service map and then use it to display in dashboard and the risk healthy checks that are visible in Ceph status. That's all of our nearly plans, and your suggestions are greatly appreciated.
Great. thank you very, very much for all the work that you put into it. There's one thing that I was planning to look at was like the support of the more complex configuration. I started implementing that. The idea there is currently the configuration that you could set on tier config is a flat key value, list of flat key value entries, and for having more complex configuration, that you might need arrays and stuff like that. So I was looking into somehow getting the JSON representation into the tier config. And I started implementing that, and it shouldn't be too hard. So yeah.
Okay. Yeah.
Right. Great. Thank you very much.
I had one quick comment about the status. Those last 2 points, there's sort of 2 parts. One is reporting, making sure that any of the sync status is included in the daemon status portion that gets reported back up to the manager. That's certainly something that can be done now, and you can always like dump it manually. The surfacing it on the dashboard is harder because we don't have the panel of the dashboard that shows even the basic RGW stuff with the zones and the daemons and whatever else. Obviously, if you folks want to work on that, that would be awesome. But I wouldn't. If you don't, then you can still get the stuff into the daemon status now, and then we'll surface it later on the GUI. That makes sense. Okay.
Okay. Thanks.
Awesome. Yep. Thanks so much for your hard work shaking out these issues. This is great to see progress here. Maybe Yehuda, do you want to just like summarize briefly what this is all? I don't know. We sort of skipped the like overview. Not everybody might be aware of what this is all. This is all CloudSync, right?
That's all CloudSync. So CloudSync is basically taking the sync module framework, which allows us to sync either data or metadata, or like objects metadata, to a separate zone that's could be in the cloud. In this case, we're using the sync modules also for the Elasticsearch metadata indexing work, and it's basically how we do multi-zone data sync also, right? Like it's all using the same infrastructure. So the idea there is when we need to do a sync, we dump the data to S3 or to another tier that's compatible with it, and eventually it might not be as compatible. We're kind of building it to be abstracted enough so that there might be some hooks to allow other cloud providers that use different authentications and different APIs. So we try not to make it very S3 or S3 specific, but currently that's going to be the first implementation. Yeah, I think that's it.
Right. Thanks.
All right.
All right. Any questions on RGW Cloud Sync before we move on? All right. I have a quick update on the DM clock stuff. This is mostly work that Eric has been doing here at Red Hat and the folks at SK Telecom. So I just wrote a few notes in the DM clock pad that I'll paste. The quick version is that right now mclock is merged. There are 2 modes you can run it in. One is mclock op class, which puts different types of operations on the OSD into different classes. So client ops are one class, scrub is one class, recovery is one class, map trimming is one class. I think that's it. And then it uses mclock to prioritize against those. There are config options to control what the relative mclock parameters are for those different classes. So you can put it in that mode, and it'll do its thing. That's all merged. The other mode is mclock client, which uses the dmclock actually to do scheduling of clients against each other, where you would have you have a minimum MIOPS or whatever for a particular client, and so on. That's mostly merged, except a lot of the sort of bits to actually configure it aren't there. So there's sort of two issues right now, is that even for the mclock op class, it doesn't work super well currently because we aren't managing the queue depth very well at the object storage layer. The queue is too deep, and so the prioritization that we do at the mclock layer doesn't really have much effect. There were a few patches to try to fiddle with that Eric and the Booster team were kicking around, but we mostly set those aside because the in-flight I/O scheduler or outstanding I/O scheduler that the SK folks were working on looks to work much better. So the current task is to get that reviewed and merged. And there's a link to the pull request. But with that, they've had very good results. So it's encouraging. So that we need to get that in shape. So that's sort of the main blocker. The other sort of outstanding architectural issue is that you can't mix the op class and the client scheduling currently. You either use mclock to schedule background work against foreground work, or you use it to schedule clients against each other, but you can't do both at the same time. So Eric is trying to sort out how to do a hierarchical sort of composition of those two policies. I'm not sure how far he's gotten along there, but that's the current path. And then the last thing is, as I mentioned before, there's sort of missing APIs in librados, so you can set what those client parameters are, so that they'll actually get used. So I don't think there's anything really preventing us from adding those in now, regardless of how effective they actually are yet, because that'll unblock all the other stuff. And for example, in RBD, being able to set those policies on RBD images and so on. We can get all that stuff in place sooner rather than later. So those are sort of the three sort of parallel next steps that are going on. And that's about it. Anybody want to add on to that? I guess, yeah, Eric's here. Anything to add? Or any questions?
So I guess one
No,
thing
that pretty much. I'm sorry, I just stepped on somebody. Yeah, that pretty much covers it. So yeah, I've got two things that I'm working on: the hierarchical version and plumbing. I haven't started yet, but to plumb in the Rados calls, and then we're waiting for the SK Telecom, and then we'll be good to go on a number of fronts there.
Cool. So I guess I was going to mention one thing we might want to start thinking about more is how to handle this kind of QoS in a faster world where we can't necessarily reorder all the requests in a queue. I don't really have any great ideas for that yet, but we can things like having the scheduling being done with our own queuing and user space at least lets us control CPU usage more, if not more finely grained control of storage utilization, which is what this is effectively doing.
Mm-hmm. Yeah, my sense is that in order for it to work in high IOPS environments, then we have to sample and do sort of a feedback loop where the sampling leads to throttling or something like that. Because we can't have a fully informed decision for every single IO.
Right.
Yeah, I don't know. I think that the good news, is that even if we wire up all the APIs around on the Rados side, LibRBD or whatever, for the user-facing stuff, that is sort of independent of what the implementation is. So if we, end up doing something that isn't really mclock, it's something else, I think it should still.
Yeah,
Hopefully
just
want the user experience.
structure should still be the same for the client-facing bits.
Yeah.
Yeah, the DM clock parameters of reservation, limit, and wait seem pretty generalizable. We would probably aim for something like that, even if it wasn't DM clock underlying it.
Yeah, and even if, for example, reservation like didn't work, you could still.
Right.
Yeah. Yeah, having others at least. Okay. All right. I just want to mention that really quick. So my other sort of actual meaty issue is PG merging. So I wrote up some notes on this. This has been, for a long time, I didn't think we would ever get to it. The problem, as you probably know, is that we can split PGs as your cluster scales up, but you can't undo the split and merge them back again if the cluster scales down or if you accidentally split further than you should have, which makes it very risky to ever split because it's a one-way street. And so even like somebody who knows what they're doing can get into a situation where they split and then requirements change or the situation changes and they can't merge again. So it's a big issue for just usability in general because it's really easy for users to make bad decisions that aren't reversible. But even for a good user, it's still a problem. So we want to solve it, but mostly for the usability, mostly because it's for the easy cases, I think. So the basic idea here is that you would set the PGP num, which is the placement behavior, to be less than the PG num. So that basically gets the PGs that were split to be sitting next to each other. And this is a similar situation after you split. They just split in place. They don't actually move. You adjust those two knobs separately. So you just, in reverse, you would lower the PGP num. The PGs would migrate so that they're right next to the thing that they're eventually going to merge with. So that'd be the first step. The second step, there's a pull request that does some of this, is aligning the logs. When you split, you basically just take the contents of the PG log and whichever PG each object lands in, it just gets moved into that log. And so the logs become sort of sparse as they're split apart. And in order to do the opposite to merge, we have to zipper them back together. So there's the pull request that I have basically makes in the case where PGP num is less than PG num, it makes all the versions that are chosen for log entries offset so that they will be able to zipper together. They'll be non-overlapping. So they always skip over they go by every two and one's either even and odd or whatever it is. But it generalizes to not just two, but n. So that's the first bit. And there's an option in there to just debug, just randomly skip stuff, just to exercise all that code and make sure it behaves with sparse things. The second part is that I think we need to have some check and feedback on those PGs that are sitting next to each other so that they know when they've reached the point where the logs are non-overlapping and they can be zippered together. Because initially they won't be. You have to actually run for a while and age out the old PG entries. And write new ones or whatever before that happens, or have some way to force that to happen by trimming the log or whatever. But once that's the case, then there needs to be some feedback back to the monitor, manager, whatever, so that you know that these things are actually, the logs are ready to go and they can be zippered, and you can proceed with the merge. And then the last thing is I think probably we want to try to make the logs line up so that they're sort of overlapping and not just totally discontiguous, or else the timeline on the log doesn't make sense. I'm not sure that actually is necessarily problematic, but
yeah,
I'm not sure. It should be. We'll get to that in a second, actually, because once I started to try to think about this in detail, I think that might be an issue. But regardless, there's that bit. But assuming you have PG logs in place, then the monitor needs to check a bunch of preconditions. It needs to make sure that the PGs are completely clean, and that the logs are non-overlapping and ready to be zippered together. And then I think it has to also make sure that in the map in which it publishes the PG num change where it gets reduced, no other change happens that's going to screw it up. It can't also mark an OSD down in that same epoch that's going to screw it up, or change something because with
Change
split,
PGPM or mark an OSD down that's in that a member of any of those PGs, right?
yeah, right, yeah, exactly. Because in the split case, the PG can be kind of in any state. You can always sort of split it in half. But in the merge state, they have to be stored next to each other, and they have to be, in a particular way in order for the merge to be possible. And I try to imagine what the case would be that would actually make it not possible, that would make the merge fail. And the only thing I could think of would be that if the OSD goes down and somebody like rips out one of the PGs with object store tool and then start it up again, that was the only thing I could think of. But I don't know. hopefully that's it.
Yeah, as long as there's no bugs that cause new entries to pop up that overlap.
Yeah. So then there'd be a particular epoch where the mon adjusts PG num down. And then when the OSD gets that map, it would have to do an atomic merge of those two PGs. So it would have to, when it publishes the map through the PG, it would have to like not do that and then zipper them together and then give that OSD map to the combined new PG. Then I think most of these are sort of trivial, like the last update would be the max, you zipper the logs together, the stats add up, and so on. The part that I got stuck on is that when you're doing peering in general, because there's a new interval, there's all this log recovery stuff that happens. So in the case of a replicated pool, you look at the longest log, and that's the one that you put together, and then you look at the peers, and then you get their info, and you calculate missing objects and so on. I think each of those, the thing that I'm not sure about is that each replica is going to possibly zipper at a different point because there might have been an in-flight IO, so they might be behind, and so they're going to merge, but they're going to be missing different objects. And if the two PGs aren't going in synchrony, like if they're not ordered with respect to each other, the log, it's not a matter of like just looking at the tail, the longest log, because one of them might have one shard that was 100 versions behind that's missing an entry, whereas the other one has one that's 100 versions ahead that got it. So like, I wonder if when they're in this like preparatory merge state, we actually have to order the IOs to those two PGs with respect to each other. Does that make sense?
Yeah, basically starting to treat them as a single PG for the purposes of IO.
For this like preparatory period, yeah.
Yeah.
Which is going to be hard. And then that's the replication case, which I think is comparatively simple. For the erasure code case, it's weirder because you have the log roll forward, and then I think you really do need to order in because they're the read. Yeah, it's like because the read modify write stuff that happens on an EC object actually basically holds up the log so that other EC operations won't roll forward, even if they're in a different object, if they're blocked on that one because the log application is still ordered. So I think that's the hard part. This is going to get really weird.
Yeah, it seems like it's going to get pretty complex to manage that merging at that point then. I guess taking a step back, if we didn't have knew that these PGs were clean, and we were able to have like a kind of a sync point where we said just pause IO for all these PGs, turn their logs to 0, and start them as a single PG now. That would cause a brief drop in IO during merging, but it would avoid a bunch of complexity.
Yeah. Yeah. If we didn't have in-flight IOs, that would definitely solve the problem. Yeah. So if we did that, then there'd be a map published that said suspend IO to this range of PGs.
Right.
And then the PGs would have to feedback that they'd done that to the manager so the monitor sees it, and then the monitor said, okay, now merge. Yeah, that's probably a better solution.
I'm not sure if that needs to go through the monitor though.
Sorry, Greg, I couldn't hear you.
Oh, I said I don't think that needs to go through the monitor though. I think the monitor can just ask the primary to do the merge, and the primary can be responsible for the ordering.
Like you're saying that the primary can be responsible for it instead of the monitors?
Yes. Yeah. I mean, we don't need to publish separate maps. We can just have the monitor publish a map that says, please do the merge, and the primary on the PGs can take responsibility for doing it because they can order it with respect to I/O for the whole set, right?
All right. So you'd have to have a map published that says you're in this limbo period where the PGs may or may not be merged. Please merge them. So that and then the primary would decide when it receives a thing whether it's happened yet or whether it should block the I/O or feed it to which PG.
Yeah.
At the prompt of.
Yeah.
And then once it's done, it would tell the monitor and then say it's done.
Yeah.
Yeah.
Because I mean, like the PG log zipper problem is going to be serious, but I don't think we need to like publish maps that tell I/O to stop, at least.
Well, you know what? Actually, if you publish a map that says the split is in progress, or sorry, the merge is in progress, then the trivial implementation of that is that the OSD just blocks the I/O, which is kind of the same thing, except the OSD gets to decide how it's done, right? Instead of the client not sending the I/O, then the OSD would just block it.
Yeah, I was assuming that it was OSD side.
So it's kind of
blocking.
Yeah, okay. And maybe the initial implementation just like sends it back off, just says I'm merging, go away, and then once it's merged, it drops the back off. Maybe that's the way to do it. Yeah. Okay. Yeah, because I think if there are no in-flight IOs, then it's like it's pretty tractable, right?
Yeah.
We could even just drop the logs, even.
Yeah, that's what I was saying originally.
Just throw out the logs, and we don't even need to do this like log alignment thing.
Right.
Just throw them out. Mm-hmm. You would basically do a one-time conversion of all the log entries to dupops.
Exactly.
And then.
Which is equivalent to trimming them down to 0 length.
Trimming down to 0, yeah. Yeah, oh yeah.
Do we have any issues if an OSD goes down while this is happening, or are we okay?
See,
the
that's
process continues next time because the PGs would still be in this state set by the monitor, I guess, right?
Yeah, I guess that's the reason why I was trying to have a model where they happen in parallel, because then whenever an OSD encounters this epic, it can just do it, even in isolation as it's rolling forward its source. So it doesn't matter if it failed and didn't see that OSD map, wasn't up at the time. So if the primary telling it to happen and it fails, then it has to then it gets really weird. Yeah, then it gets complicated.
Yeah, if we ever get out of the active clean state, I guess that's when it gets complicated, because we were assuming that we were staying active clean during this process, right?
Yeah.
So,
yeah.
Yeah. So if we can make the process idempotent, it seems like it would be okay for roasties to go down and back up again and continue the process.
So if the monitor publishes and says these PGs should merge now, they're in the process of merging. When the primary gets to that, it will basically peer, send it back off, quiescing IO, and trim all the logs down to 0.
Mm-hmm.
And then after all of that's happened. Everybody has, all the current replicas are clean. They've persisted their empty logs, and they're like clean slate, no in-flight IO. Then it'll go to the monitor and say, okay, merge. I'm ready. And then the next map that gets published and says these ones are no longer pre-merging, they're actually merged. And at that point, then the replicas will atomically just like zipper them together. Because there's no zipper or whatever, they'll merge them. And there's no in-flight AO. And they're clean. Right.
I'm just wondering if we can avoid that second OST map update.
I think once we trim the logs, there's no overlap, so we're actually okay. If someone goes down, they just have to backfill it back into place in the new unified PG, right?
I guess what I'm
great, but
what I'm worried about
is easier and less latency and sensitive otherwise.
What I'm worried about is like, say you're in the state where the primary is like, okay, I told everyone to like zero their logs, I'm all ready to go, and then it's a split, and then they crash, and so one of them split and the other one didn't. Then suddenly peering has to deal with the fact that it's like it's got 2 PGs or 4 PGs or whatever that are not yet merged reporting in, but their peering state actually affects that same PG. That's the part that scares me.
I don't know that that's any different if we do the 2-stage thing, though, right? Like,
yeah,
they still have to merge.
At the epic, at the merging is driven by the OST map, and so they'll all happen at the same time. Not at the same time, but independently. And they won't talk to each other until after they've done it. So either they haven't merged yet, in which case they're catching up on maps, and then they'll merge, and then they'll talk to you after they've caught up. Does that make sense? Then you don't have to deal with unmerged PGs talking to a merged PG. They'll atomically roll forward, or whatever.
Right. Yeah, I guess that simplifies it a bit compared to making the primary do that coordination, like during the pairing process, to determine whether the replicas need to continue the merge process or not. If it's driven by the OST map like that.
Mm-hmm.
So I think that makes sense.
I mean, I guess if we're merging, then probably the cluster is less active anyway. So I mean, I'm willing to do that, but we're talking about like it's a several second IO pause, I guess.
Yeah, it's a multi-second merge, yeah.
On every merge though, which might be okay.
So I guess the other question is, how expensive is object store merge going to be?
It should be cheap. I mean, with Blue Store, it'll be cheap. It's just like a synchronous update. I think the slow part is going to be map gets published. It has to reach all the replicas. They do an IO to like persist it and do it, and then you have to like feed back that state back to the monitor so it sees it and then moves forward.
Yeah.
I would imagine to make this to minimize the impact, the monitor should like reduce pgenome like one at a time. So there's only like one
PG,
one peach happening at a time.
I'm not sure that's.
Because otherwise,
I don't think that's something we should enforce programmatically, actually, because any RVD that hits those is going to get stuck anyway. So why?
Because what I'm worried about is if you just have the PG num, or if you whatever you prepare, you say you're merging half of them, then all of those PGs, or at least ones that are sort of contiguous with the top, have to say that they're ready before you can actually reduce the PG num and finish the merge.
Oh, that's true.
And so you might have one straggler that like blocks the whole thing.
Yeah. Okay, that's true.
So it's a trade-off of OST map updates versus tail latency for a large number of PGs.
And in general, to minimize the impact, you just do it you'd only want one PG to like stick IO for 2 seconds, and hopefully most people won't notice that. It does mean that if you're going from like 1 million PGs to 500,000 PGs, like it's going to take a while.
Yeah.
Like I feel like that kind of doesn't matter because they're already placed in the same place, so it's like it's a small amount of work based on what you already paid to like migrate the data to get to that point.
Yeah, this is a background operation that shouldn't really be expected to be low latency. That is, we're probably going to want to like throttle them anyway, so that we don't have too many going on at once and impacting the cluster in general. So.
Yeah. Well, at least that's a workable solution, I think. So that makes me happy.
Yeah,
maybe we can have something better, but at least we have a solution. I was scared because when I was thinking about this before, I thought that in my mind it was clear how it had all come back together, and then when I started thinking about this again yesterday, I realized that what I was thinking before didn't work at all. But this I think would work. So
that's what you said last time.
yeah. Now there are 3 of us. So, okay. All right. That's all I got.
All right. So I guess the next is the Ost refactoring topic, which is a bit of a broad one. We already talked about this a bit at the beginning, but to reiterate, the background for this is that in general, much faster devices are becoming more prevalent, and over the next probably 5 to 10 years, we're going to become most likely even more common, perhaps than hard disks. So we want to start preparing for that now before we have to do hundreds of thousands of IOPS on each OSD. So we want to start think about the end state to actually get good performance out of these super fast, almost memory speed devices. And that probably looks something like a shared nothing architecture where we avoid doing as much work on the CPU as possible for each I/O. So one way to do that is to chart all the work on a per CPU basis, have basically no locking and no memory barriers as much as possible, just using message passing and the copy memory bit essentially between different cores when we need to, and running everything either in a single process or multiple processes, but with minimal overlap. And eventually getting to a point where we're doing all of the scheduling, network I/O, and storage I/O in user space, most likely with DPDK for the network and SPDK for the storage devices. So in terms of actually scheduling the code, there's many different approaches and ways you can format this, but the way we're currently structuring the code with lots of callbacks everywhere is pretty difficult to reason about, because the callbacks just kind of get thrown around every which way and spread throughout different layers. So you end up reading through things in many different places to figure out a single strand of execution. And it also ends up using many heap allocations and locks. There are a bunch of different frameworks, of course, around asynchronous programming, but one of the promising ones is futures and promises, which essentially allow you to structure asynchronous work as a single threaded strand of execution in the code. Doesn't one aspect of this will be restructuring a bit of the OSD code to be non-blocking in as many places as we can currently, so that we can use more these kinds of like futures-based frameworks for A, making the code easier to reason about, and B, eventually minimizing the allocations we need to do. So we've been looking at a few different libraries and frameworks that provide tools for futures and asynchrony. There is a standard future library in C++, as well as Boost ASIO framework that wraps around that basically. It doesn't really provide a whole lot more beyond the basic building blocks. You have to kind of build your own things around that in terms of scheduling and the event loops and dealing with everything else in the system. Make it asynchronous. Another one is Tokyo, which is actually in Rust, which looks very promising in terms of minimizing allocations. They have a clever way of using the type system to convert chains of futures into a single allocation upfront. So that basically it compiles to a state machine so that it can be one block of memory and going through and executing within that block of memory without having to do new allocations for each new task or chunk of work to do. That might be a promising direction to go if it's possible to implement that in C++, that same kind of framework. Then the third one we've been looking at more is C*, which is designed exactly for this kind of shared nothing architecture with very high speed polling-based interfaces for networking and storage. Although it does now support non-polling modes too, so you don't have to use the 100% CPU all the time if you're not using super fast storage or if you can't dedicate cores to something yet. The actual futures model it provides is more similar to the standard future or Boost ASIO than to Tokyo, in that it does do allocation still for each future or for each task, but it is using its own per core allocator by default, which is a bit more efficient than something like tcmalloc or anything else that would need to do its own locking and memory barriers. It also makes it also has primitives that are already available for doing all the user space scheduling and prioritization and grouping different tasks into different priorities and executing ones that are for executing the same function or code, for example, together, so that you keep the instruction cache hot, or chaining them together so that you can keep track of groups of tasks together, that kind of thing. It's also a relatively new early form framework in that it doesn't actually do any releases yet, so they recommend using it as a submodule. And the major project that uses it so far is ScyllaDB, which is by the same people who wrote C*. So seems like it's still a relatively early project, but has very useful building blocks to work with.
I keep hearing Tokyo come up. Is it possible, or does it make sense to try to make these interoperate? Like, if we wanted to build something like Tokyo, would we be able to use it in the context of C*, or would we be able to build that Tokyo style framework in C* or something like that?
Yeah, so I think we would be able to, if we built a Tokyo style framework in C++, we would have to modify the C* reactor, which is the event loop basically that runs different tasks, to use that kind of as those types. I'm not clear on how extensively we'd have to modify C* to make that happen. If it would involve, like, for example, rewriting all of the utility functions to use the new types, or if you could just kind of do a drop-in replacement.
This feels like it would be a conversation to have when you're like locked in a room with a C* developer.
Yeah.
And ask them, like, this is why we think that the Tokyo framework makes sense.
Right.
Is that correct, or is there a way to achieve something similar in C*? or whatever. Yeah.
Yeah.
Isn't it
And
a question whether you would whether you need to or whether
yeah, the other question is whether you need to as well.
Yeah. Yeah. Those are nice to have.
Right.
Yeah.
It may be that the C stars per CPU allocator is sufficient enough without having to do all the memory barriers and cross-core locking that we don't even need to worry about that piece of it as much.
And if we just went with what the C star model is now, does the code that you end up writing substantially differ from what you would get with is this a totally different way of structuring things?
So the code you get with like the C star style futures versus Tokyo futures would be very similar. But any of these would be kind of drastically different from the current code.
Yeah.
In similar ways.
Okay.
The main one being that you can't block anywhere in any of these threads. And once we actually do have sharding per CPU, we can actually avoid locking almost everywhere in the IO path, at least.
One thing that's really cool about C-Star's futures is that they're integrated with the reactor. So they don't have to assume that you might complete from a different thread, so there isn't synchronization.
Exactly.
Yeah.
And a while ago, Arit mentioned that C-Star is looking at implementing or integrating with C++ coroutines, which are a technical specification that's still in progress. But being able to use coroutines instead of futures would eliminate a lot of extra overhead also. So I'm really excited to see what happens there.
Yeah, that'd be interesting to see. Do you have any more information on latest there, Casey, or is that just a potential development?
I think there was a pull request or something on C-Star's, is it Google Groups or something? So there is code, and I think it got some review. I know that the latest Clang has an implementation of the coroutines that you could play with, missing some of the standard library stuff. But yeah, it's still pretty early for that.
Interesting. Yeah.
Josh,
I would consider it ideal if we could mangle the C star futures into looking like the Tokyo ones and use the rest of their infrastructure. Personally, and it's not just about how fast the memory allocation is, but it means that we can do so much of it up front, so we have a much better lock on how much memory is available to us in case of trouble, which ties into what Alan was talking about with us at OpenStack's age, about sort of having the assigned bundle of memory. And I still need to look at it more, but I was sidelining with Sam some this morning before we did this, and I actually think we can do that in C++. And make it look pretty. So that would be the ideal thing. But we've got to get some more people in a room to look at how C-Star works and what adjustments we can make to its type model.
I think that's kind of orthogonal to converting the existing OSD code to be able to run this model at all.
Well, it depends on which pieces of it we think we need to get done in the first pass. But yeah.
Rick or Josh, have you guys run into anyone else that's struggling with this same kind of question? Is this being discussed by other folks as well?
I had a conversation with I forget the name of the company. It's somebody that we've talked to a long time ago. They ended up not using Ceph and writing their own thing, proprietary, but they basically spent the last 2 or 3 years rewriting the whole thing to be DBDK and C-Star based. The only real takeaway I got was that it was a lot of work, but it paid off. It was totally worth it. So.
Did they consider Tokyo, or were they looking at other things too?
I don't think so. I think they just went with the thing that was there.
Tokyo seems like a thing that you could evolve towards over time, but it's solving different problems and using a richer set of semantics from further up the stack. It's interesting.
It kind of feels like the bigger question initially is just what would it take to make the already big step to use D-star unmodified.
Right.
And what do we need to do to get there? Because it's like all the locking model is totally different. The sharding. So I mean, we have all these. There isn't that much that blocks in like the messenger stuff is all asynchronous, so there's no blocking there because it's all sort of already compartmentalized behind this interface.
Right.
And we can presumably make a wall around the object store, and so there's nothing really in between that blocks except for like, get attribute or something. But we still have like so many different threads. That
Yeah, so
I don't understand what the model is. I guess I don't know.
Yeah, so I guess ideally we want to get to a point where we don't have the op queue anymore, at least for the entire OSD. We want it to be sharded, so that we don't have to do any memory barriers there or any locking there. And at that point, get rid of the PG locks since they're all sharded as well. But getting rid of the PG lock probably implies changing a whole lot of code to be safe to run exactly on one core and make sure that it's only running on one core and not touching any of the structures outside of that. And similarly with any kind of the OSD code that's not down in the PG. I guess there's a few things there that just for like gathering stats and reporting things to the monitor and handling maps and whatnot that we need to think a bit more about how to do in a completely sharded world.
Yeah, well, and also everywhere we do synchronous reads needs to look like a new kind of code.
Yeah, file store would not be...
which is the big thing in the op path.
Like that, we assume the object store is not like blocking for now. We just have a thread pool that runs everything for the object store.
At least a lot of maps. Yeah. Yep. Yeah. So I mean, the thing I've been trying to do with the pairing work queue is to basically just get everything into one work queue, into the op work queue.
Yeah.
That's still helpful because it's consolidating, so there's a single interface for all the work, right?
Yeah.
Yeah. We definitely want that.
Okay.
We just want N of them instead of one.
Yeah. Okay. All right. Well, I'll continue beating that one down.
Yeah, because we still do want the unified queue for each individual shard, right? We just don't.
Yeah, and I mean they'll shard the same way we do now. PGs will be assigned to cores, so that's all. That's all good.
Okay.
This actually sounds supposed to be rational. I'll be hopeful that we can have some periodic discussion in the perf call. Maybe to look at ways to do iterative prototyping pieces of things.
Yeah, I think that's a great idea.
Yep. Maybe we should talk about this on a weekly basis at least.
Yeah. I think we're getting far enough that'll start being useful. If anyone can prototype a tame reactor so we can start using C-star inside of the OSD, that would be great.
Yeah. I think that's the challenge.
I thought Casey was eager to take that up, but
I think Adam was invented the term, so maybe he has to.
Okay. One of them.
Tame in this case.
Yeah, I'll meet with Adam and brainstorm and see if we can come up with something.
Okay.
We did have it's kind of hard dealing with external threads because message passing between C-star threads happens over like each pair of cores has a single producer, single consumer queue to pass messages. So I think an external thread would have to generate some kind of similar mapping. But once you have that, I think that gets you most of the way.
I'm not sure it would even need to be that parallelized. We wouldn't have that many. Well, no, I guess we would for the object store, right? Okay.
I mean, a prototype that isn't fast at all but just works would be a start, right?
Yeah.
And the goal would be to eventually not use it. But there's at some level, there's going to be a thing that we're going to have some random threads that are out there, like, for like the admin socket. I don't know, all the like sort of random sideband crap.
Right.
So,
well, actually, I mean, like the admin socket could run somewhere. That's not a big deal to just have a reserved core for handling certain kinds of things.
It's like shelling out or whatever, right? Like there are cases where we do like random asynchronous flow stuff.
Yeah.
In a separate thread. So.
But anything with sockets is one of those places where it's relatively easy to convert to asynchronous code.
Yeah.
Yeah.
I mean, like the object store is the model to worry about for sure, because we're not going to be able to make that integrated until we have something other than RocksDB, I guess.
Yeah, so looking at like SoliDB is interesting because they actually do implement some kind of what do you call it? What's the LDB structure? The same kind of tree.
Oh, the SSTs.
The SSTs based structure. But SoliDB is AGPL, unfortunately. So maybe we can talk to those guys and see the SoliDB folks and see if they're willing to relicense that.
What's the license?
AGPL.
Oh, a Pharaoh?
Yeah.
Wow. Okay.
Not really a source code license at all.
That's the one where if it's a SaaS service, you have to share your code, which makes it incompatible with GPL and whatever else.
I kind of looked through their code and it doesn't look like there's a real convenient way to do kind of the equivalent gets and puts as just like a simple key value store as there is in like RocksDB. It's kind of this table oriented.
Yeah. We want like a low level flat table store thing.
Yeah. I was kind of curious how hard it would be to implement some kind of lockless B plus tree type thing in C star.
That's the thing, though. I think if we do go full share nothing, we don't really want any lockless like shared state at the object store level. We might even want independent object stores for core too.
Or to shard it somehow.
Can we still want some kind of central log though, right? We always want to have everything appending in order to a log for like PG log and debug updates, right? We don't want to. Oh, I guess on SSD it doesn't matter, but we always want.
They could be sharded. There's the one sort of piece that sucks is that the snap mapper is cross PG right now. That's the one bit of object store state that doesn't shard properly. I haven't come up with a way to fix that, but
okay, yeah, I'll take a look at that more closely too.
I don't know.
I guess the other thing I'm less familiar with on the networking side is with DPDK. I guess essentially you need one process that is the only one responsible for the network card, which sounds like it's one core handling all the network traffic and then passing off the work to other cores.
That is, I think you can tie it to a VIP, whatever you call it, virtual function, instead of the entire card.
Okay.
This is how they carve up a single NIC across a bunch of VMs. But still, mostly yes. So it'd be like an IP address per process, I think what that means.
So that potentially means one process per core instead of sharing.
Well, no, it means I think the assumption is that one core would be enough for servicing the network.
Okay.
Yeah, I think that's the assumption. And if it's not, then you have like two processes on the host. One per socket or something like that.
Yeah. And that's something we can certainly worry about more later as well. Not a pressing concern at the moment. But
yeah, I think that it doesn't sound like it's going to be an issue, but the thing that I worry about or wonder or whatever is that we need to make sure that if we don't do like vanilla C star, that we can still interoperate with the DPDK and SPDK that are happening on the other end.
Right.
Josh, going back to sharding the database, can we really get away with that? I mean, that would be fantastic if we can, right? But
I mean, it's equivalent to running multiple OSDs, right?
Yeah. Yep.
It like multiple OSDs on the same device potentially.
Yeah, potentially.
With the same trade-offs, right? Where you're not necessarily getting good behavior on something that likes sequential I/O.
Possibly. My assumption was that usually you'll see more devices than cores, but that may be invalid. I'm not sure.
I think that's right. I think right now for a single NVMe we're using like 3 cores or something like that. Is that roughly right, Mark? But that's
more,
too much.
But
we want like one or less per less than a core per NVMe.
Yeah, but I mean, more devices than cores is. Don't think I've ever seen a configuration like that, even when you're using hard drives.
Oh, there definitely are. I mean, when people use those like 72 disk chassis, right?
Yeah, but I thought those guys were usually using dual socket systems to serve them up with like 16. Yeah, but maybe only 2. Maybe it's 2 to 1 in those cases.
Yeah, you still don't have that many cores.
Yeah, but even at that, I'm more thinking like, okay, if we're doing logging for PG, right? Don't we want all of those log entries to come in to a single log rather than splitting them off into shards that each are independently logged?
The log is per IO, and so I'm not sure it'll matter too much. Unless you're talking about you can consolidate them when you're batching them up. If it's not sharded, then your batching will be more efficient, I guess.
Well, I guess how does it... Go ahead.
I mean, these devices all have like a bunch of different lanes. So I think sharding is you need all that parallelism to like keep the device busy anyway. I think sharding at some level is the way to go.
In the hard disk case, I guess is specifically what I'm meaning.
Yeah, no, the hard disks aren't going to care about this, but
yeah.
At that point, I mean, we're not going to care either.
Right.
If you're
down there.
I mean, for the hard disk case, we'd probably continue using BlueStore. Like, we wouldn't need a specialized backend that was able to do shared nothing.
If you can tie BlueStore into it effectively, I guess, using whatever.
Well, that's definitely going to have to happen. We're not going to have a new object store before we're ready to start deploying this code. That's why we need a tame reactor or something, is so that they can interoperate effectively for a long time.
Yeah. So Josh, then just in this world where we are targeting this thing at very, very fast solid state storage, then the idea would be we get away entirely from this idea of shared log, shared database. We just shard the whole thing out, right?
Exactly.
And then we don't even target anything that requires a different behavior.
Yeah, pretty much. And for, I mean, which things that are requiring different behavior are you thinking about?
That was exactly it in the hard disk case, with like a case where you don't want to be logging to multiple independent logs and spreading IOs across the disk, right? Or different places having
but I mean, presumably at this point we'll be fast enough anyway that we can drive a whole hard drive with one CPU, so it doesn't matter, right? Like, we'll give it as much as it can eat and absorb at a time.
Yeah, I think for the hard disk case we'll end up not using any polling because it's not necessary, and so we just go back to the thread pooled object store in the back end and The front end is simply a bit faster with however many shards we need to use.
In that case, you just end up with a single shard.
Most
at
likely,
that
yeah.
level. Yeah. Okay.
So there are probably a bunch of things that we'll have to change for this, but one that comes to mind is our existing debug logging. I think we're probably not going to be able to do almost any of that.